today the second day. First, we are going to start with the program, with the award function. Later, it is followed by the commercial session. Then our technical sessions is going to start. So be ready with your, I request all the commercial session members who are there, please give their PPT to our ED people, electronics people, where they can upload your PPT, PowerPoint presentation, or whatever the details you have.
Also give their name.
Give their name so that we can easily call you to move forward. Now, for the award function, I kindly request our the president of the Indian Water Works Association, Engineer M. Madhiyalan sir, please occupy the dais, sir. And I request the immediate past president, Subhash Bhujbal sir, please. Our vice president, M.L. Agarwal sir, please. Then our secretary, general secretary, B.K. Parida sir. Then Ilangovan, the organizing secretary, engineer Ilangovan, the organizing secretary, and the joint secretary of this today's program, Sir Chalamuttu, present chief engineer and the secretary of the Coimbatore Center, Sir Chalamuttu sir. And Ravina Naik, the joint secretary of the Indian Water Works Association, Ravina Naik. All the members are requested to please occupy the dais so that I will pass the mic to our secretary, Parida sir, to continue. Sir, General Secretary sir, you can continue further, please. Yeah. I request once again, the commercial session is going to start immediately after the award function. Please hand over your PowerPoint presentation to the electronics people so that they can really upload your whatever the materials you have. After the commercial session, again, the different technical programs are going to start. In the commercial section, one technical paper is also there. Our former chief engineer and the former president of the Indian Water Works Association, Dr. Ramanujan Saab, is going to present the paper. The first paper will be presented. Later, we are going to start up the commercial session. That session, whatever the technical session we are going to start, the commercial session, which is where B. Srinivasa Reddy, the former managing director of Karnataka Urban Water Board and the former president of the Indian Water Works Association, is going to chair the session. At the same time, again, along with our engineer T. Srinivasan Saab, you are the former chief engineer of TART board. They are going to chair the session. That's commercial session. Now, the program for the award section is going to start. I will pass it to our Parida Saab. Please.
Good morning, everyone. A very warm welcome to all present here. A special thanks to the chief guest of the, guest on the dais. It is an honor to greet you all. Without wasting time, we will start the presentation ceremony. I will request the award winners to be ready to come to the dais so that time can be saved. We will start with Brijnandan Sharma Award. This award is given from donation of rupees 50,000 given by Mr. Brijnandan Sharma and is given every year to a young, energetic engineer whose age is less than 40 years and who has outstanding career and also who has done substantial work for the Indian Water Works Association. Nominations are invited from the young engineers through their respective centers. The candidates are required to submit their biodata in detail, giving information about the work done by him for IWWA and also the commendable work done by him in his career. The prize consists of certificate and memento. This year's awards goes to Rishikesh M. Kaluskar, Pune Center. I will request our president to Mr. Kaluskar, please give him a hand. Congratulations. The next award is Sri Kencha Reddy Memorial Prize. This prize is given from donation given by the family of late Mr. Kencha Reddy in his memory. It is usually given to the author of best article on water distribution system published in the IWWA journal during the year. A committee under the chairmanship of the honorary editor of the journal with 3 members is constituted to recommend suitable article for this prize. The prize consists of certificate and memento. This year's award goes to Engineer Venkatesh J, Engineer Ganesh D. Kale. 2 members combinedly their paper was published in the journal and they are being awarded for the best article. Mr. Engineer Venkatesh and Engineer Ganesh D. Kale. Congratulations to both of you. Congratulations. Next is PV Patki Memorial Prize. This prize is given from the donation of rupees 5,000 given by the family of late PV Patki in his memory. This prize is normally given to the author of the best article in the IWWA journal during the year. A committee under the chairmanship of honorary editor with 3 members is constituted to recommend suitable article for the prize. This prize consists of certificate and memento, and this year's award goes to Engineer Vijay Kumar A. Kakade. Engineer Vijay Kumar. Anyone from the concerned center can also receive the prize on his behalf. Center, anybody from the center? Which center is not written now? Engineer Vijay Kumar and A. Kakade. Okay, we'll pass it. Next is Sri S.B. Patavardhan Memorial Prize. This prize is given from the donation received from the family of late Mr. S.B. Patavardhan in his memory. It is usually given to the author of best article on water treatment plants published in the IWWA journal during the year. A committee under the chairmanship of the honorary editor with 3 members is constituted to recommend a suitable article for this prize. The prize consists of certificate and memento. This year's award goes to 2 authors, Engineer Srivendra B.T., 3 author, Engineer Binaya A., Engineer Sputi S.S. Congratulations to all. Please receive the prizes. Next is Sri SP Onwala Memorial Prize. This prize is given from the donation received from some senior members in the memory of late SP Unwala. This prize is given to the best article in the IWWA journal during the year. A committee under the chairmanship of honorary editor with 3 members is constituted to recommend suitable article for this prize. And this year's prize goes to, this prize consists of certificate and memento. On this year, prize goes to Engineer Muhammad Anas. Engineer Muhammad Anas. Is he present? Anybody from his center also can collect the prize? Huh? नहीं लिखा ना? Okay. So we'll go to the next award. Dr. P.R. Bhabe Memorial Prize. This prize is instituted as proposed by Dr. Rajesh Gupta and others from Nagpur Center in the memory of late Dr. P.R. Bhabe, retired professor of civil engineering, Visvesvaraya National Institute of Technology, Nagpur. Dr. Bhabe is renowned worldwide for his work in the area of water distribution network, and he was the member of IWWA. He passed away in 2011. It is usually given to the author of the best article on efficient and economical water distribution system, published in the IWWA journal during the year. This prize will be in the form of certificate. The award for this year goes to Engineer Shubham Kumar Sanu, Engineer Chandrakant, Engineer Kavya Agrawal, Engineer Bishavraj Sharma, and Engineer Amrit Raj Bajaj. Are they there? Anybody from their center also can collect the prize. Nagpur Center. So I will request Chairman Nagpur Center to collect the prize on their behalf. Anyone from Nagpur Center? Okay. Next is Dr. Constantino Feliace Friends of Active Adivasi Trust Award. This award has been instituted from the donation of rupees 1 lakh received from Dr. Constantino Feliace Friends of Active Adivasi Trust in the year 2008. This award is usually given to a male or female who is young engineer and hydrologist and have at least 5 years of their professional activities contributed to alleviate or to solve water scarcity problem for poor people living in tribal areas, for poor farmers working in arid and semi-arid areas. This award consists of certificate and memento, and this year award goes to Arun Sastrakar, Amaravati Center. Is he here? Anybody from Amaravati Center? Okay, next. Prizes for best lectures. The IWWA centers undertake a number of technical programs during the year and arrange technical lectures on various subjects throughout the year. These prizes are being given to the best lecturer in the center. Usually one lecturer who has delivered the best lecture in that center is given this prize every year. Recommendations are invited from all centers for these prizes. The prize consists of a certificate and memento. From Mumbai Center, the prize goes to Ullas Paranjape. If he is not there, someone, from Mumbai Center is requested to receive the prize on his behalf. Next is best lecture from Minut Center. The prize go to Sarvesh Kumar. Anyone from Minut Center can receive the prize. Sarvesh Kumar. Then prize for best lecture for Amaravati Center goes to P.D. Bhamre. If he is here, he is requested to receive the prize. Otherwise, anybody from... okay. Okay, next is best lecture from Odisha Center. Is go to Sri Chinman Tripathi. He is not here. Anybody from Odisha? I mean... no, so many people are there, so many people are there. President, chairman, anybody, they are there, they can come. Yeah. Mr. Adil Muhammad is here. Next is best lecture from Pune Center. The award goes to Mrs. Prajakta Baste. Mr. Patel will receive on our behalf. Next is from Nagpur Center. Best lecture from Nagpur Center is go to Udayan Srauti. If he is there, he is there. Nobody from Nagpur Center is there. Next is best lecture from Raipur Center. It goes to Sri Philip Ekka. Give him a big hand. Next is best lecture from Indore Center. The award go to Engineer S. Sudeep Bhatnagar. Yeah. Mr. Qureshi will receive the award on behalf of Bhatnagar. Next award is a certificate of appreciation. These certificates are normally given every year to one or two centers which are at distant place from metropolitan areas having less jurisdiction but who perform various technical activities and various programs to achieve aims and objectives of the association regularly throughout the year. This prize consists of a certificate and a memento. The award goes to Miruj Center. Certificate of appreciation to Miruj Center. Give them a big hand. Next is Sri V.D. Deshpande Memorial Prize. The prize is to be awarded to a person who is active member of association, planning various programs, conference, seminars, convention, etc. for association, and extended dedicated service for a considerable period of hour, keeping away from holding any office bearer post or such honor. The award consists of certificate and memento. This year's award goes to Engineer A.G. Nampurkar from Pune Center. Heavy factor. Congratulations. Then certificate of appreciation. This is under Youth Forum for Water for individuals. The Director Youth Forum for Water of Indian Water Works Association instituted the awards in the form of certificate of appreciation to given every year from the year 2019 to an individual at the age of 20 to 25 who has done extensive programs such as dramas, skits, articles, video, films, case studies, considering them as future potential leaders, ambassadors of IWWA in water management sector as a team leader. Nomination for this prize is to be made by the center. This prize is given in the form of certificate and memento. This year's prize go to Mr. S.B. Baira Reddy, S.B. Dayanand Sagar College of Engineering, Department of Civil Engineering Department. Give him a big hand. Moria S. Dayasagar. Okay, next is also Mr. Moria S. Dayasagar, same for certificate appreciation, Youth Forum for Water. Mr. Moria S. Dayasagar, Dayanand Sagar College of Engineering and Department of Engineering, Bangalore. special thanks to Dr. Ramaraju. I mean, yeah, because of guiding the students very well. This ends the award and prizes giving ceremony. I will request Mr. Elangaman to give a vote of thanks. Oh, sorry, to Mr. Chalamathu. Who will give?
One more award is there.
Yeah. Oh, sorry, organizing committee wants to give some award to the students of colleges or school? To school or college? Schools. Schools, I will. Huh.
This is for here.
Yeah. I will request Mr. Srinivasan to actually announce the award. Yeah.
Good morning, sir. Good morning, gentlemen. This is the awards given to students. We have conducted the program for last 1 year for propagating the water conservation on behalf of Coimbatore Center. This is all school students. We will announce that they will be honored. Only the first in competition will be honored. Thank you. Mr. K. Kanitka, 6th to 8th standard category in elocution. That is Panchayat Union Middle School, the government school, primary government school. There is a rural school. And name B. Durga, Selvi B. Durga, 8th standard. This is a Corporation Government High School, Selvapuram. Coimbatore Corporation Government School, Selvapuram. Yes. Baby S. Sandhya, 9th standard, Corporation Government Higher Secondary School, Oppanakara Street, Coimbatore. Next, R. Geeta, 12th standard, Corporation Higher Secondary School, North Coimbatore. Next, A. Gudbul Jesran, 11th standard, Model Higher Secondary School, Corporation School, Araspuram. Next, okay. V. Varsha, next V. Varsha, 10th BRT Girls Higher Secondary School, Anamalai. This is also rural school. Very good. with the gathering permission and on behalf of Day's permission, thank you. With all this success, one of the NGO, AIM, has provided all the facilities for conducting this all competitions. I request Mr. Tirunavukarasu, Director AIM, to get a felicitation from our President. Thank you. Thanks to IWA headquarters. I'm handing over the dais to Secretary General, IWA. Thank you.
Request our Joint Secretary Rabina Tandon. Oh, sorry. Rabina Nayak. Sorry. Rabina Nayak. Oh, she just like Rabina Tandon. No, it's. Yeah. She'll give vote of thanks.
A very good morning to all of you. I hope you all are enjoying the conventions. I would like to thank all the dignitaries present on the dais and off the dais, all the people who have got awards, especially the students. They are the bright future of our India. So I wish them all the best for the coming future. And I thank everyone present over here. Thank you so much.
This ends the prize giving ceremony. Next.
One small request. Tomorrow morning we are having technical tour. For that, who are all interested to attend the technical tour, ask them to present here by 9 o'clock, return back by 2 o'clock.
Okay. Sir will tell. Sir will tell.
No, sir. The technical tour, field visit tomorrow.
Now, this ends the prize giving ceremony. Now the technical session will start. I will hand over the mic to Dr. H. Ramaraju. He will go ahead with technical session.
A small announcement to the delegates. Technical tour will be arranged by IWA Coimbatore Center tomorrow morning. This vehicle will be available at University Center, this hall, around 8:30. We will come back around 1:30 for lunch. Those who are interested, please give the name to help counter. Thank you very much.
Where all it is possible, we have accommodated. Where all it is possible, all the first chairmen, they much almost. Some of them they have not come, they told clearly. Songaria Sabah, they told, no, we are not coming. Then we come. Almost all everywhere is involved. Friends, now let us go to the other session. Now we have to start with the commercial session. I would like to invite the session chairmen, our B. Srinivasa Reddy, past president and former managing director of Karnataka Urban Water and Drainage Board, sir, and present chairman of Indian Water Works Association, Bangalore Center, to tell more about the Professor Srinivasa Reddy. He is a strong man, specifically his knowledge and other things, his vast experiences. Now he has become a philanthropist. He is running an ashram and he is running a temple trust, Ramanshi Ashram and all. And he is doing a lot of social activities also. Now, it is a time for me to tell proudly that the Bangalore Center under his chairmanship, now we have allocated nearly 2.5 to 3 lakhs per year to give the fellowship as a stipend or a project, a seed amount to the students of the engineering colleges. Almost 212 engineering colleges are located in Bangalore. Now we have got, we have invited the students to submit the project proposal. Once the proposal submits, we will review with the committee as been formed. We will review it and selected maybe 50 to 60 proposals will be given with a cost varies from 5 to 10,000 rupees. We are going to sanction, the Bangalore Center is planning to sanction the amount to the student to see that as a seed amount, they will start up the project, they will do the project effectively. That is the idea behind it. We have to thank Srinivasa Reddy for taking an initiative from that one. Now I would like to invite our T. Srinivasan Saab, former Chief Engineer, Tamil Nadu Water Authority Development Board. Sir, Srinivasan Saab. Srinivasan Saab. I think he is somewhere here. And he is the organizing secretary also. I would like to invite Srinivasan Saab to sit on the dais. Now, both they are going to chair the session and they are going to conduct the program. First of all, I would like to invite one of the speaker of the day. First, we are going to start up with the technical talk where Dr. Ramanujam was the managing director of Kerala Water Authority, and he has served in an effective way in the department. And he was the past president of Indian Water Works Association also. Sir, I kindly request you to deliver the talk. I think your PowerPoint is given to our ED people. Yeah, you please. I think, yeah. Soumya, madam. Soumya. Please collect the PPT and hand it over there so that, sir, we can give the deliver of the talk. Fine. As per the commercial session is considered, 3 names have been given. L&T, Dr. P. Ganesh Kumar is there. Then Phoenix Reaction. Then Electro-Steel Castings. They have to give the presentation. Now, anyway, once the presentation is over from Dr. Ramanujam Saab, the things can be taken up. Now I'll pass it to the session chairmen, B. Srinivasa Reddy Saab and Srinivasan Saab. They will take up the further things, please. Thank you, sir. Sir, please. You can sit, sir. They will start. Yeah. Notice, sir.
Is it audible? Hello. Hello. It's okay. Yeah, very good morning to all. Hello. The attendance is quite thin. Nevertheless, we'll go on with the program. The first paper is from Mr. Ramanujam. He was the president of IWWA, past president way back in 2002. When I was the vice president, then I became the president in Delhi in 2003. He became the immediate past president. So we were president and presidents almost 20 years back. He was MD Kerala Water Authority at that time. I was MD Karnataka Urban Water Supply and Drainage Board at that same time. Both of us were there. So that's about both of us. We are close to each other from a sister states. I request now Mr. Ramanujam to present his paper. About 15 minutes time. Thank you very much. Left side. Left.
Good morning to you all. I am going to present a paper named Solution for Water Authorities and Public Health Engineering Departments to reduce cost of production of treated water. A sample study was done by me, getting data of KWA, Karnataka Water Supply and Sewerage Board, and Toad Board. Based on that, it was found that about 390 crores per annum and 400 crores per annum can be saved for in connection with production of treated water. And you all know that rapid price increase is happening to various commodities in India, just like petrol, diesel, gas, electricity, and other commodities. But as far as water supply tariff is concerned, hike of tariff is somewhat difficult due to political reasons. And usually the water authorities or PHED gets some assistance from respective government for their day-to-day activities. Now, most of the governments are thinking that water authority and PHED should be self-sustainable, and the government is not going to give any assistance. In this connection, this paper too much valid and eye-opening subject. Next. After a study, we just made an average cost of production of 1,000 liters. It is something about 24 rupees per kiloliter. After that, major amount goes to electricity. That is 10.8 rupees out of 24 rupees per 1,000 kiloliter. If we are able to reduce that electricity component, actually the production cost will drastically come down. Is it possible? Yes, it is possible. We will see how it is possible. Next. The solution to reduce the electricity charges is to go in for solar power and use the solar power for various operation of electromechanical equipments for the treatment of water. There is a classical example that has happened in Kerala, that is Nedumacheri Airport, that is Cochin Airport, is completely run by solar power plant. So it is possible for water sector also. Next. How this solar power is tapped? There are two ways. One, off-grid system, and other is on-grid system. Off-grid system means the DC power generated from solar plant will be stored in batteries. So the maintenance of the battery is very expensive, and it is found that this is 40 to 50% more than that of on-grid system. On-grid system is simple. We produce solar power, convert that DC power into AC power, and connect it to the nearby electricity board network. From where we can tap the electricity for our purpose, for respective treatment plants, etc. Government will decide what is the modus operandi for selling power to EV, or even they can decide a service charge will be levied for using their network. So, for a water supply system, the on-grid system is preferable and it is economical. Next. Next. These are the representation of on-grid and off-grid system. Next. Next. So these are the advantages. On-grid system capital investment is 40 to 50% less than the off-grid system. For water authorities and PHD, on-grid system is preferable and viable. How power connected and taken out in is measured. Use net metering system. The advantage, suppose we have a solar power system in Coimbatore and we have an excess production of electricity, you can take that in Chennai. This is how electricity board will regulate the supply of this solar power. That is the main advantage. Next. Before we analyze how the solar system is going to help the treatment water process, treating water, this parameter should be remembered. 1 megawatt is 1000 kilowatt. Panel area requirement, 10 square meter for 4 kilowatt hour unit. And the installation cost is about 6 crores for 1 megawatt. Now in the market, there are branded companies panel with a reduced area, and we are going to get 1 megawatt very easily. And the cost of these panel plant has reduced to 4 to 5 crores. Next. The panel warranty is 25 years. After 25 years, there will be some reduction of 10% performance in the solar power plant. These are the data available and received from the water authorities and PHAD. And power cost per year is given here. I will take the example for average 10 MLD. What is the power consumed is given in the first column. Power cost per month and power cost per year is given. Next. This is the scenario of Water Authority Kerala. So capacity of solar plant required, it is given for 100 MLD, 9 megawatt will be required for that plant. And the cost will be 54 crores. And payback period for 100 MLD plant, it will be somewhere about 4.5 years. Next. Sample calculation for 100 MLD. 1 megawatt solar plant will produce 4 megawatt. Hence plant capacity, as I already told, it is 9 megawatt. Cost of installation of 9 megawatt solar plant is 54 crores. Panel area required will be 89,785 square feet. Square meter. Next. And this arrangement, what are the main advantages? Payback up to payback period, if we take 24 rupees as production cost for 1,000 liters, it will work about to 86.4 crores per year. After introduction of the plant, solar plant, if we consider at 13.2 rupees per 1,000 liters, it will be in the order of 47.52 crores. So reduction in cost of production and water will be 38.2 crores. So that is a saving. Next. Next. So in short, goal achieved are reduction of production cost of treated water, indirect benefit, power network gets more electricity and energy for distribution. Solar power energy is utilized effectively. As I told, this can be used anywhere in any districts. Next. This is some example of configuration of how plant is constructed. Next. This is the some summary of 50, 100 and 150, 200 MLD plant. And you will see for 100 MLD production, there is 38.88 crores savings, and 200, it is 77.76. These calculations are readily available in the souvenir. Next. If we go for 1,000 MLD to be operated by solar power plant, the total production cost at present rate will be 864 crores. And after introduction of solar power, it will be pruned down to 475 crores. And saving of production cost per annum will be about 390 crores per annum. Next. And capacity of the plant required will be 53.25 megawatt. If we go for 2,000 MLD production, and it will be about 800 crores per annum, we will have the savings on account of this solar power plant introduction. Next. Where solar panel can be installed? Solar panels on floating platform in reservoirs, dam, lake, some of the possibilities in Kerala is given there. Rooftop of treatment plants, pump houses, top of ground level tanks, rectangular OS tanks, etc. And in semicircular or flat shaped solar power park is the ideal one where land is available in the state.
2 minutes.
And nowadays, Bosch and Tata Power Solar companies are giving effective solar panels. Next. So, conclusion, water authorities could switch over to utilizing solar power for operating treatment plants and machineries at least for 50% of total production of treated water for economizing water treatment cost. By utilizing solar power to produce 1000 ml treatment plant, water authorities are expected to reduce expenditure to the tune of 390 crores per year. It is advisable that the solar power plant provision may be provided in the estimate and budget for future project. Grants, soft loans, central government provisions, ADB, JICA, and other donor agencies can be approached for financial assistance. Even subsidy is available. Amount source saved per 1000 ml production can be utilized for salary, pension payments, and for maintenance purpose, etc. IWWA may pass a resolution to the effect that solar energy to be utilized for water treatment units for reducing water treatment cost so as to get water sector self-sustainable. These resolution may be submitted to respective state, central government, and water authorities for implementation. For information, Kerala Water Authority has decided to go in for solar plant, and board has taken the decision based on our representation. Thank you for listening to this eye-opening subject. Thank you.
Yeah. Thank you very much, Mr. Ramanujam. Please come. Now I request the next three presenters to come on the dais and sit here. L&T and Dr. Ganesh and another Electro Steel, Phenolex, Ella Bane. Phoenix. Sorry, I could not. No, it's fine. Yeah, Bani, where? Secretary will come. No. Okay. The past president. Oh, General Secretary. Come, Mr. Ramanujam. So honoring and.
I request the session chairs to honor our former past president of the Indian Water Association, Dr. Ramanujam, sir, please. Thank you, sir.
So, kindly, Phoenix is there, yeah. No, most of them are known to me, some of them, but the new. Yeah, no, I retired 17 years back. L&T, Electrosteel, they're all, we worked together as a suppliers and a agency, executing agency. Mr. Jagannathan is a country head now. Jagannathan is, yeah, L&T Jagannathan was there with me. And now I request, actually these are the people who are the mainstay backbone of our conventions. Because their support is very much essential, and that's why maybe they're a little late for presentation. In the sense, we call them late, and I feel little embarrassed to give them a little lesser time. Please don't mistake me. But nevertheless, you can take another 5 minutes more than what is supposed to be given. Now I request Dr. P. Ganesh Kumar from L&T to make his presentation. L&T.
Good morning, all.
Yeah, around 15 minutes.
15 minutes. Sir. Thank you, sir. So, good morning. Thanks to Indian Water Works Association for giving an opportunity for us to present our technical presentation on our own patented project, attached growth batch bioreactor, to this esteemed forum. And really, actually, if you see, L&T is also one of the corporate member in Indian Water Works Association from long time, and I am also one of the live member from an IWWA from 2005. Yes. Yeah. So today's presentation I'm going to cover is attached growth batch bioreactor. This is the technology we have developed for the treatment of domestic wastewater application. Next slide. The presentation I'm going to cover the next 10-15 minutes is about L&T overview in water and effluent treatment sectors. And this is the need of the technology, why we have developed in the in-house technology attached growth batch reactor. That's salience
one second.
of the AGBR. And
So this electronics department, why it is not coming on the screen here? Oh, gentlemen, you see, it's not coming on the screen here. Set it right, I said, they have to see back.
it's a yeah. Yeah. So L&T overview on key challenges in wastewater sector. So L&T is in the water and effluent treatment for the last 2 decades, I can say. So we have, next slide. The overall business overview we see in water and effluent treatment, we have water and wastewater SBG, where we are taking care of rural water supply project, urban water and water management, and wastewater collection and treatment and reuse. And we have irrigation, industrial and infrastructure SBG strategic business group, where we are taking care of large water systems, lift irrigation project, industrial and desalination, and smart water infrastructures. So like developing a city, we are developing the smart infra facilities. And we have presence in Water International, where we are doing treatment plants, water effluent, as well as sewage treatment plants, and we are doing water supply in international business also. Next slide. So our client list, mostly we are doing with our esteemed government clients. So in India, we have 83 clients. 90% of them are government clients like PHED, FART Board, CMWSB, BWSB, everyone. And in the Middle East, we have 5 clients, and East Africa, we have 2 clients. So totally, globally, we have total 90 customers across the globe. Next slide. So in the past track record, if you see beneficiaries, because of our business in water, almost 95 million people are getting benefited. And irrigation sector, we have irrigated almost 1 million hectares of the land. And drinking water treatment plant and supplied, we have done almost total cumulative of 7,200 MLD. And wastewater treatment plant, we have done almost 2,100 MLD total. And smart infrastructure development, we have done 7,500 hectares. And wastewater network, we have done 0.5 million kilometers. Next slide. So coming to wastewater sector, key challenges in India. So as already our esteemed speaker, the past Ramanujam sir explained about the treatment plant power by means of solar. But the challenge here is, So the challenge is the intrinsic need of power saving in enhancing the sustainability in operation. If you see the report published by IIT Plus Consortium, 54 STPs they have done, the maintenance and then check the functionality of the sewage treatment plant. Out of that, the main challenge is the power. So there's a need to minimize the power while running the sewage treatment plant. So that is the one challenge we are facing across the country. And as per the CPHO standards as well as NGT guidelines, there's a need for total nitrogen and total phosphorus removal. So there is a need for a compatible technologies to addressing the challenges of nitrogen and phosphorus in the wastewater treatment itself, the need of the hour. And then again, the big challenge is land stress. So any sewage treatment plant or any technology we are providing, the land is the challenge. How we are minimizing the land, that will give better benefit to the stakeholders. So land is the stress is the challenge. So considering the three factors, we have analyzed the need of the in-house technology. If you see, this is a conventional process flow diagram for a sewage treatment plant. So pre-treatment is same. So removing floating materials, grid materials, primary treatment systems, these are common for everything. And any sewage treatment plant, any technology, the most critical is, heart of the system is biological system, which is called secondary biological treatment system. So there, the technology is vary, and the tertiary treatment is common. So if you see again the secondary biological treatment, there are two processes, broadly I can say in terms of biological process. One is the attached growth systems and the another is suspended growth systems. The attached growth system, again if you see there are various technology. If you see moving bed bioreactor, again it came from the Noxcon is a company from Norway. Now it is taken over by Veolia. It's imported or foreign technology which is implemented in the country, I can say. And fixed bed film activated sludge process, again FBAS, it's again developed from Hungary. So similarly RBC, rotating biological conductor, and then activated sludge process, even 1904, the technology was developed in UK by Floor and Arden. And the sequential batch reactor in the last one and a half decades, if you see across the country, 80% of the technology, sewage treatment plant operated in the country is with SBR. So again, it came from Austria and then it is implemented across the thing. So everywhere the technology is dependent on our foreign nature. So why we need to develop we can utilize we have our stalwarts, Srinivas Reddy sir and all, we are helping us in the long time and guiding us to improve ourselves. So we have understand the benefits of attached growth, suspended growth, and then why in-housely we can develop a system called attached growth batch bioreactor. So it's a combination of both attached growth as well as suspended growth, and then advantage of continuous flow as well as advantage of batch process also we have taken, and the system is developed. How we have developed this system, if you see. So to start with this, we need a fundamental research. So for that, we have signed a MOU with Anna University. It's a premier institution in the country. I understand our director, one of the inventor of this technology is Dr. Kanmani ma'am. This is the director of Center for Innovative Studies. He is also here. So we signed a MOA with Anna University for doing the fundamental research. The results was good. Then we want to take it in the pilot scale. So we have done the extensive study of almost 2 years in pilot scale at Anna University campus, taken the sewage from the same campus. So this is a photograph. If you see, our Chief Technology Officer, Mr. Jagannathan, is there at the date of inauguration of this pilot scale, and Professor Kanmani is the Director of Center for Innovative Studies, and Vice Chancellor Surappa, and our IC head, Mr. Rajavel, was there. So we have found the results are good. The pilot scale results also was good. So then the novelty, why we can file for the patent, applied for the patent, and we got the patent. So what is technology? So when we are compared for SBR, how to reduce the volume and then how to reduce the power is the main challenge, and how to reduce the sludge. So we have introduced a media made up of polyester, HTP, acrylic biofringe we have imported from Japan, and then polyalkene, it's an indigenous developed media in India. So we have tried for all the things in the batch process, lab scale. Then we have found both polyester is not good, acrylic fringe even is good, the cost base is not economical. So we have done with the HTP as well as polyalkene. That study we have taken for pilot scale. The results are good. Then we have applied for patent and got. So how the reactor looks, this is the attached growth batch reactor. Since there is a need for total nitrogen, we have introduced the anoxic zone. And then the media zone for the volume reduction is the second zone. And then third zone is like a batch mode. We have to make a filamentous flocculi bacteria. So it's like a advantage of SBR is taken in the third zone. So aeration is done in the third zone also. So these three zones is provided in our system. And if you see the innovation and the uniqueness of the solution is, this is the first kind of special hydrophobic polyalkene media is used in the systems where it's give more surface area. If you see that MBBR media, the surface area is almost 800 meters square per meter cube, whereas the media what we have developed and what we have used in our system is more than 1,500 meters square per meter cube, so which is giving more space for the microorganisms to grow. And this system, the third zone, since we have provided, it gives enhancement of settlability, which can improve the treated water quality, especially for the total suspended solids as well as total nitrogen less than 10. So this process is continuously as given the consistency, the biological nutrient profile is happening. So here also we have eliminated this mechanical decanting so that the cost can be minimized, as well as the total depth of the reactor can be utilized. And this is like a modular, and it can be developed for any scale. So we can able to make for, so 15 KLD we have done it at our research center, and then it can be scaled to up to 100 MLD. So this is the uniqueness of this technology. And this is the media. If you see, this is the media we have provided in the central zone. So where it gives the space for the microorganisms. The microorganisms of anaerobic culture will be in the base layer, and anoxic culture in the middle layer, and the aerobic culture in the surface layer. So it is simultaneous nitrification, denitrification also happening. That is the advantage of the systems. This is a comparison of the technology delivered. This report is prepared by IIT consortium plus consortium developed by Professor Tare. So we have made a comparison along with our technology. We can able to see the savings of less than 10% on the footprint, 15% on power, and 25% on the sludge reduction. So this is the technology we have implemented in one of the STP at Madurai, at Theravada Arts College. Again, thanks to Dr. Chandran, who has given the opportunity to us to implement. Again, Dr. Chandran is the IWWA Madurai chapter secretary. So this is the systems. If you see, this is the existing system we have rehabilitated. Existing systems was removing only BOD, and then the flow was less. So existing capacity is 60 KLD. We have improved with 100 KLD with the nutrient removal. So this is the water quality we can able to see at the plant at Madurai we have done. And then see, if you see that water quality, what we are achieving at Madurai plant, the BOD less than 5 consistently we are able to get, TSS less than 5 we are able to get, and COD less than 15 we are able to get, and total nitrogen less than 10 consistently, and total phosphorus less than 1. So if you see the recent CPHO guidelines for tile flushing issued by CPHO in 19th December 2023, the guidelines says if the water is used for reuse or tile flushing, BOD they are insisting for less than 6. So with this our systems we are able to make it. This water in Theravada Arts College they are using for gardening. It can be used for tile flushing also. So when compared to conventional SBR, AGBR, what is the advantage we can say is power reduction by 10%, footprint by 15%, and sludge production by 20%. So the recognition from statutory bodies for implementing in Tamil Nadu, the High Power Committee formed, we have presented to Tamil Nadu Pollution Board Chairman, that time Mr. M. Selvam, Member Secretary, and IIT, Anna University, and the CMWSB, they said to implement for Tamil Nadu. And for discussing with CPHO, we had a discussion with Dinalin sir and team. So sir said to make it for 1 MLD and then we can put it in the CPHO. So this is the patented technology. Along our joint partner is Anna University. And the internal accolades and recognition what we have received is PI Award. It's one of the prestigious awards within L&T, and the Golden Peacock Award, this technology we obtained from Golden Peacock Innovative product. So that's about the technology. Once and again, L&T is focusing now on water technologies and the research component. So I'm showing 1.5 minutes video. So what our research focus, L&T water and effluent treatment is focusing. This is the 1 minute video about this.
Endeavor to constantly evolve and stay adept in the growing climate of technology based on the futuristic requirements. The development of the first of its kind, Water Technology Center at Kanchipuram, India, is one such progressive move. The center is defined to be an exciting space that offers highly specialized research and development in the entire gamut of water, including biosolids management, valorization, and value recovery from waste and membrane technology innovations. The Water Technology Center is intended to be a G+1 structure, occupying overall 65,000 square feet and situated in a lush, sprawling green 10.5-acre L&T campus. The center caters towards addressing the global water challenges by applying actionable water intelligence with key verticals: R&D Center, Artificial Intelligence Data Center and Knowledge Hub, supported by 5 laboratories and a unique prototype zone. The collaborations with different premier institutes and organizations aims to implement explicit research work at the center with value addition in the collective sector. The Technology Center has strong community of researchers and engineers well versed in different domains who work together in teams and is divided into 2 groups for research and product commercialization. Key vision of the Water Technology Center is committed to fundamental, methodological and practice-based research with focus on continuous R&D to innovate scalable solutions, enabling L&T wet IC and beyond to meet present and future water needs, to build a safe, resilient and sustainable ecological systems globally.
So this technology center is the focus of our chairman as well as CTO's vision. So, yeah. So I request all the delegates and then the government officials, whenever you have time, to please visit our water technology center. It's the focus for doing that applied research, catering to the country's need. And regarding this technology attached gauge batch reactor, the working model, physical model is available at our stall at 99 in the stall area. So please visit. If you have any questions, we can discuss. Otherwise, I will pass on to the mic to the audience. Thank you.
Yeah, I think it's all self-explanatory, Dr. Ganesh Kumar. Thanks for an excellent presentation. And nothing needs to be explained because L&T has covered everything probably on the globe. So thank you very much for your presentation. Come, please. Who is presenting? Electro Steel. Your good name? Yeah, now it is by Mr. Chandrasekhar, Electro Steel presentation. Thanks.
Good morning, all of you. We from Electro Steel Castings Limited, manufacturers of ductile iron pipes and fittings, thank IWWA for giving us an opportunity to give presentation on DA products. We thank you all water engineers and official concerns for using DA pipes and fittings in various projects. We produce almost all DA components involved in a water supply networks, pipes, fitting, flange joints, and restraint joints, which is newly developed. We are glad to update you on DA pipe enhanced capacities and size ranges and newly developed mechanisms for joints. We cordially invite all delegates to our stall number 8 to review our product physically, which are also covered in this presentation. So though many of you know about electro steel and also familiar with the technicalities of DA pipes, we once again like to quickly recall about the company as well as the product specifications and the manufacturing process. Manufacturing process video, please.
Metallurgical coke from imported coal. A comprehensive coal handling and blending mechanism helps in achieving high coke yield with optimum coke quality. Pig iron is produced using mini blast furnace from high-grade iron ore, low-ash metallurgical coke and fluxes. The deslagged molten pig iron is safely transported through ladles to the induction furnace at the DI spun pipe division. The pre-analyzed molten metal is superheated in an induction furnace. Inoculation of magnesium converts the flaky graphite structure to spheroidal nodules, resulting in the birth of ductile iron. Molten iron is poured into the casting machines in the water-cooled spinning mills. High centrifugal force helps to form pipes of uniform thickness. The pipes are removed from the molds and are subjected to an annealing process, which relieves the pipes of stress and helps them to gain the design properties. The pipes are zinc-coated to enhance the inherent corrosion resistance. Every pipe is subjected to hydrostatic pressure test for soundness and leak tightness. This ensures that the pipes are free of surface defects, cracks or blowholes. Later, the pipes are internally lined with cement mortar. The cement-lined pipes are cured in a steam chamber and later ground for perfect surface finish. The finished pipes are externally coated with bitumen as an extra corrosion protection measure. Epoxy coating is also done on specific requirements. The finished socket and spigot shree pipes are duly marked with automated stenciling as per IS 8329 and sent to the dispatch yard.
As you know all, Electro Steel Castings Limited pioneers in ductile iron pipes in India, has more than 6 decades of experience in water inflow business, and we are the largest manufacturer of ductile iron pipes in the Indian subcontinent, having a production capacity of 708,000 ton per annum. Our manufacturing activities are spread over 5 different facilities. Now we are the largest producer of ductile iron pipe in India and third largest producer of ductile iron pipe in the world. We have a strong brand presence around the globe. Our pipes and fittings are exported to more than 110 plus countries across 5 continents. And we cater to a large customer base spread around the Indian subcontinent, Europe, North, South America, Southeast Asia, Middle East, and Africa. We are the largest exporter of ductile iron pipe in the nation. Electro Steel Castings Limited has technically advanced manufacturing units located in Srikalahasti, that is in Andhra Pradesh, Karda, Haldia, and Vanperia, that is in West Bengal, and Elavar in Tamil Nadu. So quickly, we want to recall again the unit-wise manufacturing capacities. One is Srikalahasti Works, located in Andhra Pradesh. It has the size range of 100 to 1200 mm, having the S&S socket spigot pipe capacity 5 lakh ton, and then the flange pipes of 7,200 metric ton, whereas Karda Works, West Bengal, has got 80 to 1000 mm size range, having a capacity of 2,80,000 metric ton, and DA fitting of 10,200, and wrist chain joint systems, which are a new product that we'll talk about in the subsequent slides, has got the capacity of 12,000 metric ton. Haldia Works, with again size range of 80 to 1200, which manufactures exclusively DOA fittings and flange pipes. And Bansperia is a dedicated plant for the ultra-model coatings and linings. So total our capacity is, for socket and spigot, is around 7,80,000 metric ton, and the fittings is 21,000 metric ton, flange DA pipes are 13,800, and wrist chain joint pipes are 12,000. Yes. This is just many of you know about the product specification, but though just to refresh you, we just brief you about the ductile iron socket spigot pipe specifications and even fittings and flange pipes. Come to next slide. Socket and spigot side pipes are in conform standard of IS 8329 with the subsequent amendments, and size range is 80 to 1200 mm, and length is 5.5 and 6. The linings will have a Portland slag cement and sulfide resistant cement and high element cement. These are all done in internal linings. External coatings we have zinc and finishing layer of bituminous and epoxy coat. Similarly, we have rubber gasket conforms 5382, which is used for the jointing. And the materials of rubber gasket is EPDM, and the dimensions of the rubber gasket suits for the socket dimensions of the DA pipes. We have a nominal sizes of 80 to 1200, which have the thicknesses of 5 mm to 15.3, having the allowable operating pressure ranges from 80 to 64 bar. Next slide, please. And fittings, standard conforms IS 9523. Size is again is 80 to 1200. The class is K12. The linings are similar to S&S pipe, socket and spigot pipes. And coating is also similar to socket and spigot. There are specific requirements which can be done for the fusion bonded epoxy coats also. And ductile iron flange pipes, they have a wide range of products here, wide range of applications. Double flange pipes, double flange puddle pipes, single double flange pipes with a puddle, which are all used for the embedding in the concrete wall structures, and flange spigot pipes with a single flange pipe, flange socket pipes, which are nothing but tile pieces to make use of at the valve locations. And in flange pipes, again, we have two types of flange pipes, that is welded and the screwed. Welded, we have the size range of 80 to 1100, of the pressure rating pin 10, 16, and 25, length up to 5.4 meter. And screwed flange pipes, we have a size range of 80 to 400, having a pressure rating of PN 10 and 16, length up to 5.4 meter. As-cast flange pipes also available, and the size range from 80 to 1200, which has got the pressure rating of PN 10 and 16, length up to 1.2 maximum. Next slide. So though many of you know about the advantage of DA pipe because being end user of these, we just want to quickly again refresh you about the corrosion resistance capabilities of DA pipe. Due to high carbon content and silicon, DA has inherent excellent corrosion resistance, and push-on joints especially interrupt the flow of stray current, which will be reduce the susceptibility to corrosion and the cross-country pipelines. Deflection of pipes, DA pipes are designed to resist IRC class AA loading, and which has got a high flexibility of joints, which also absorb the external loads and the ground movements and the surge pressures, seismic conditions, reducing the risk of cracking or failure. Handling DA pipe doesn't require any racings inside, and it is easy to lay and join, and it also requires a less working space. Installation, ductile iron can be used in any diverse conditions, site conditions. It also can be used in slushy and waterlogged area.
Please.
Yes, sir. I quickly run through. And reduce maintenance and longer service life. Next slide. So this is the new upgradation of jointing system in DI. This is called technically restrained joint pipe system. This is to eliminate the thrust block, requirement of thrust block at the bend locations, as well as wherever the cross section reduces in the pipeline network or pipe has to be ended. So, the introduction of, as you know very well, it is a well-known fact that hydraulic thrust forces are developed due to change in directions of the pipeline or reductions on the cross-section area or blanket ended. Your conventional methods are you are placing a thrust block behind all these kind of deviations that occurs in the pipeline network by using thrust blocks to resist the thrust forces. This is the normal practice and it's conventional methods. Whereas if you come to normal push-on joints, without proper placing thrust blocks, it may be susceptible to the joint leakages. So to alleviate this kind of problems and to eliminate thrust blocks completely and to alleviate the problem associated with thrust blocks, we have introduced a new jointing system called restrained joint. Come, slides. Video, please. Yeah. 5 minutes, sir. Only 1 minute video. Yeah, yes, yes. This is the socket profile, sir. This is the normal Titan rubber gasket, which is hosted inside the groove, the socket. And this is the plain end. Plain end will have a projection, unlike normal S&S pipe, which is pushed by alignment. If you look at the cross section, you can see the rubber gas inside and the weld build projections. And placing the locking bars in the locking chambers, the left and right. Left locking bars and right locking bars. Jointing is done. And the rubber spacer in between to keep intact all these two metal bars. These locking bars are also of DI. We'll just show you one more case study of a 1-minute video. They are all, we call this name as electro-lock pipes, though technically it is called restraint joint pipe.
The electrolock system is based on
These are all the case studies in the France.
The Titan gasket lock system primarily consists in.
And this is the fitting. Fitting also will have a similar chambers to host the locking bars. Lubrication is done. Pushing, because this is a cross-country pipeline, they are doing it above ground. Once it is done, it can be lowered in the trenches. Right locking bar, left locking bar, the right locking bar. And the spacer bars. Next slide. This is one of the scheme in JJM, sir, in Odisha. These pipes have been laid near the railway tracks, where you expect a lot of vibrations while the train passes. Similar mechanism adopted here, without placing thrust blocks. Yeah, next. Yeah, next slide. So main applications of restraint joint system is to eliminate thrust block completely wherever pipeline changes direction, and where the space is not there for the having a thrust blocks, and the transmission where there will be regular diggings or there will be the existing utility shifting. These are the ideal places for restraint joint system. And main importantly, bearing capacity of the soil pore. So where you expect there is a settlement during various conditions when you go for a construction activities. So even the subsidence of the joint beneath the earth beneath the pipe will not affect this kind of jointing system. Next slide, please. Key advantages. This is the final part. Key advantages: pipelines can be executed faster, no need of additional space. Shifting of underground utilities not at all required. You can eliminate the destabilization, and it can be used for the trenchless also. Next slide. Come. Pressure bearing ability, you can see from 80 to 1000. Allowable angular joint deflection is 3 to 5 degree, and pressure bearing ability is 25 bar to 64 bar. Next slide. These are the projects where it is already used. Okay, sir. Come, next project. And these are the projects, the DBOT-based projects specified. These are recent tenders done in Kerala, Andhra, Telangana, and of course Jammu, Kashmir, Uttarakhand. Come next. These are the projects in abroad. In abroad, it is already there since 2019. It's almost 5 years now. This is working perfectly well. Come. Next. These are the test setup located in our plant, Srikalahasti. We all invite you to have get acquainted about the test setup and the pressure bearing ability of these kind of joints at our plant. So you are welcome to this. And thank you very much, sir. Thank you for your patient sharing, and have a good day ahead.
Oh, thanks a lot, Mr. Shekhar. Thanks. I'm sorry it was a little more time there. It has gone to them. Maybe I'll be a little more. I have to be a little more unfair to the next other two presenters. I just don't know. The main problem is actually we should give them at least half an hour time for at least 20-25 minutes each. The problem is lot of time was taken away by the presentations, and most of the fellows for the presentations, people that never turned up. The respected General Secretary is here. We should cut them off now from the further any applications of this thing. Unless we are very serious to these people, how many? I was counting Eight people were not there. 8 of them were not there. It's a total this thing. And what is it? At least we could have given so much of time for them. They are the people who are supporting us in such a big way. And we'll see that next time it doesn't happen. Thanks a lot. Come along, please. Next is Phoenix. Phoenix. Yeah, good name. Yeah.
Phoenix Contact.
Yeah, Phoenix Contact.
Sorry? No, we had only given that. Presentation we had only given. Yes, sir. Yeah. Good morning all, and let me introduce myself. My name is Naresh Kumar, and I am from Phoenix Contact. Phoenix Contact is a German company. This is just brief about the company, that who we are and where we are placed. We are a German company having the 11 global sites, manufacturing units. India is also having one of them. And we, as of now, we have completed 100 years into the market, and we are having 20,000 employees across the globe. And 75% of the revenue comes from the globe and 25% of our Germany headquarters. We have more than 1 lakh products. So this is how we have established ourselves. We have already completed 100 years. We have founded ourselves into 1923. And then gradually we have established our different units at the different locations. And the first product we have developed was the connection technology. And now we are talking about more on the IoT things or maybe the automation technologies. So you can see this is our growth in the 100 years, that how we have grown parallelly. In last 1 day, the topics we have discussed, you can see here, we have spoke about sustainability and efficiency, then the water quality, then the better infrastructure, and many so things. But the main topic I would like to highlight here is, because nowadays we are growing more towards the digitalization, or maybe the automation, you can say, into the water infrastructure. And water infrastructure is not going to be a conventional thing, it's going to be a very critical infrastructure in coming years. So the topic which I am trying to make you more focused into the industry is cyber security. So cyber security is how important for this water industry, because when we are moving towards the automation or maybe the digitalization, then you never know who is coming from the back door and what he is trying to make the changes which is going on here or maybe somewhere else, or during the operation into your plants, or maybe he is trying to fetch the data from your systems, or maybe he is trying to shuffle some funds, or maybe there can be different possibilities. So we have to be always careful while we are designing any project or maybe considering the automation things into the project. So you can see here, this is one of the data which we have collected from one of the study. And you can see here in 2017, there were some hackers who has, in the industrial control systems, they hacked the system and they influenced the things, they influenced the plants, and they are not stopping. They are continuously doing the same things in today also, or maybe tomorrow also. And every day we are, listening or maybe hearing or maybe reading the news into the newspapers or through the different medias that someone is doing, the cyber hackers or maybe the cyber frauds are happening with the different ways. These are some cuttings from the newspaper you can see here, and in India also we had the many incidents. So we are not away from that kind of the threats. This is one of the maybe event. Everybody knows that blackout in Mumbai. So that was just because of the cyber threats. This is brief about some important laws and the standards which talks about the cyber security, or maybe we have to be careful about or how we can improve the infrastructure. So here one IT Security Act is there, 2015, which speaks about or maybe which defines about that digital things, that how you can secure themselves. Then BIS standard is also there, and when we are talking about the industrial control systems, then there is one standard IEC 62443. That is the very critical or maybe the important aspect or important standards you have to consider while you are selecting the automation or maybe the control systems into your plant. Security by design according to IEC 62443. This is the standard which we are talking about. So when you are designing, when you are putting the specification, then you have to consider this standard. And this standard is very, very comprehensive. It talks about the system, it talks about the system integrator, it talks about the hardware, each and everything. It includes all the things which need to be taken care for the security of your automation system. You can see here that this particular standard is further bifurcated into the 4 sections, and if you will see here, role of the asset owner, then the system integrator, how they can be important when they are putting the systems at place, and then the last one is hardware, which is very, very critical, which is very, very important. If the hardware is not in compliance with the IEC 62443, then nobody can make sure that your system is going to be foolproof against any cyber threats. So whatever the hardware is used for the automation, because sometimes we overlook or sometimes we are very less concerned, because water is a charity for everyone. Everybody thinks about, I think yesterday we had discussed a lot, that everybody is expect, free of course, the water. So when we are expecting something free, then maybe the system integrator or maybe the contractor or maybe the end user, because they are having their limitation on the financial things. So again, if you are putting maybe today one infrastructure and that infrastructure is going to be disturbed by someone remotely, so all your efforts maybe go fail. So I would request, whenever you are putting, because this is a very, very small subject in the water infrastructure, we are more focused on the pipes or maybe the civil structures or maybe the other things, but we have to look into this subject also. So Phoenix, how it placed or into the water infrastructure. So we have a PLC Next technology which is certified as per IEC 62443. With this technology, you can make sure that whatever the automation system is there, that will be protected completely. It has the very latest, advanced features, role-based access, or it has the inbuilt firewall also, so that nobody can access, and maybe unintentionally or intentionally, he can't, give any disturbance to your systems coming into your premises also and remotely also. This is one of the particular model, AXE F1152, which we have been already supplying to the JJM project in the different state also, and we had already supplied into Amrut project also and the NMCG project also. This is another that is also certified as per IEC 62443, and it's completely cyber secured. You need not to worry when you are putting this system into place about any cyber attacks or maybe the threats. This is the third model we have with the different configuration, because based on the number of IOs, number of the instruments, and criticalness of your plant or the capacity of the plants, we have the different models. So these are the three which we have highlighted over here, just to make sure that these are, we have been already supplying. And this is the certification you can see here, as per IEC 62443, it's a third-party certification, and all the products or maybe the model number which we have shown, all these are certified as per this particular standard. We are not limited to the control systems. We have other devices also. In my first slide, I mentioned that we have more than 1 lakh products. So whatever the water projects you have, into that we can contribute you somewhere, maybe for the small extent and maybe somewhere in very large extent also. So we have our manufacturing facility in Faridabad, close to Delhi. There we have maybe more than 35,000 square meter plant, and we have very latest technology machines and the equipments, and there we are manufacturing all these products. Projects we are working, so these are the 3 missions of the Government of India, and our state is have their own maybe target to complete these very soon, maybe in coming 1 or 2 years. So we are well placed into it. We are working with many of the states in small or maybe the large scales. And you can see here, this is the list of the project which we had already executed in the many states with the different authorities who is taking care these projects. Sir, I'll take only one or 2 minutes, not more than that. Yeah, thank you so much, sir. You can see here, these are some latest projects where we had already supplied, and you can see here that where we are, associated with all these industry stakeholders from the different. These are some approvals, but we are not limited to this. We have, many more, and if maybe we get the chance to work with any of the authorities or any of the maybe the stakeholders, so we would be happy to associate with them. With all this, I thanks to all for listening us, and I hope I stick to the timeline also given by the session chair. And I request to all, we have one stall over here, and stall number 129. So please do visit our stall and meet our team and have the physical feel of our technology or maybe the solutions we have at this time. Thanks again to all and the IWWA team for giving us this opportunity to present ourselves, and we will be definitely in touch with you in future. Thank you once again. Yeah, thank you, sir.
Thanks. Yeah, this is Deccan Carwell. Please come. 10 minutes. Actually, 11:45, the other session would have started. 11:30 was the tea time. Please bear with another 10 minutes, and we'll complete this and go for tea. Thanks.
Deccan
Carwell. Hey.
Good morning. Myself Arun Kumar from Deccan Industries. It's our company profile. Deccan Industries, the manufacturer of Deccan brand pump sets, was founded in the year 1981 by our engineer K.K. Velusamy. Engineer K.K. Velusamy, a well-revered technocrat, developed innovative range of pump sets to suit the diverse topographical conditions of the country. These new innovations capitulated the company to be among the top pump companies in the country. Carwell brand was established in the memory of Engineer K.K. Velusamy. The technically superior Carwell vertical open well submersible holds the highest number of models with BE star rating. These pump sets provide higher output with lesser power. Carwell open well submersibles are available till 300 kilowatt rating. Next slide. It's It's our borewell submersible pump set. The product range is from head range from 15 to 500 meter. The discharge is 30 to 2000 LPM. The maximum overall diameter of the pump set is available from 3 inch to 10 inch. Outlet size is 32 to 150 mm. The motor is available both in single phase and 3 phase up to 90 kilowatt. Advantages, that is a high starting torque, rewindable motor, high voltage operation. Mainly application is sprinkler irrigation, mines, agriculture and pumping from deep tube wells. Next, it's a open well submersible pump set. The head range from 15 to 400 meter. The discharge range is up to 10,000 LPM and the outlet size is from 32 to 150 mm. It is available in 3 phase up to 67 kilowatt. It's a closed coupled submersible pump set. It is available from 5 to 130 meter. That discharge range is up to 1000 LPM. The outlet is 32 to 80 mm. It is both available in single phase and 3 phase. This is mainly used for the distribution of water supply systems. So vertical turbine pumps. The flow is available up to 2500 meter cube per hour and head up to 200 meter. And delivery size, it's up to 400 mm. It's available in both 960 and 1450 RPM. The MOC construction is casing is cast iron and stainless steel, impeller cast iron, bronze stainless steel duplex, shaft stainless steel, discharge head cast iron fabricated steel, and a column pipe is of IS 2062 ERW. And application is mainly the water supply engineering, irrigation, process industries, water intake for thermal power station. It's a submerged vertical turbine pumps. It's a unique product of Deccan. Flow available is 2000 meter cube per hour, head is 200 meter and delivery size is 400 mm. The speed is available in 960 and 1440 RPM, power range up to 300 kilowatt. That vertical turbine MOC is same here also. Its application is also same, but only thing, the motor and pump we can submerge inside the sump itself. It's horizontal split case pumps. It's available from flow available up to 1550 meter cube per hour and head 145 meter. And the delivery size is 65 mm to 250 mm. Speed 1440 and 250 RPM. Sealing is gland packing and mechanical seal. Material of construction is casing cast iron, NI cast iron, stainless steel, and impeller also cast iron, same. Excess is bronze, soft stainless steel precision ground, and sealing is gland packing and mechanical seal. Stuffing box is cast iron, bearing housing is cast iron. So application is water supply engineering, industry utility service, cooling towers, oil process industries, power generation plants, sugar mills, dewatering plants. It's a sewage, non-clog sewage submersible pumps. It is available up to 800 meter cube per hour, head up to 55 meters. Delivery size is from 65 to 250 mm, and the speed is 1450 and 2850. MOC available is casing cast iron. Impeller we have with cast iron and stainless steel. Shaft stainless steel precision ground, sealing mechanical seal. Application for clean water containing solids up to 10 mm grain size as a sump pump for household application for draining flooded rooms and tanks, water from ponds, flowing water pits. And the solar water pumping. Solar water pump is a system in which the pump set is powered by electricity provided by several photovoltaic panels. The limited availability of grid power and constantly rising cost of fuel makes solar powered water pumps are the perfect alternative for farm irrigation. By opting for solar water power pumps, farmers are able to obtain consistent water supply. We have that MNRE required solar pumping. We have the ranges of what that MNRE specification we can supply others. And Deccan industry now is also in the business of EPC contracting in the fields of water supply, irrigation and drainage. A number of prestigious projects with infiltration wells, electrical stations, and transmission lines, pumping stations, water transmission pipelines with various materials, treatment plants, sumps and overhead tanks have been completed by us. Designing, supplying, installation, commissioning of pipes are undertaken with allied civil works. Deccan Industries, being a pump manufacturer, a critical component in schemes ensures the quality and timeline of the project. Our in-house project engineering department has the capability to do detailed project report including requirement study, site survey, hydraulic design, cost estimation, scheme execution, commissioning with operation and maintenance. Next, this is the main point, energy efficient pumping solution. It is estimated that the cost of pumping machinery is less than 5% of the total life cycle cost of a pump. In a life cycle analysis of 10 years, the power cost exceeds 85% of the total cost. There exists an enormous scope for power saving in pumping. Efficient pumping not only reduces the power cost but also provides environmental safeguard. Our in-house energy efficient pumping solution team is equipped to do detailed energy audit for pumping system, suggest solution for optimal pumping, supply, installation of energy efficient pumping machinery and electrical controls. We ensure the committed energy savings are attained. Sir, national awards received. Thank you. Thank you for the opportunity.
Thank you. Sorry for the pressure applied.
Session Chairman, Shri Srinivas Reddy Saab and T. Srinivasan Saab. I request Parida Saab, the Honorable General Secretary, to come on the dais. Anyway, let us complete the process. Let's wait. I request them to honor our. Parida Saab. The former chief engineer of the TAD board. I thank both session chairmen for conducting the this session very smoothly. Where PowerPoint presentation is there, please. Friends, anyway, now we are going to start the technical session. The presenters are requested to hand over your PowerPoint presentation details to the technicians who are located in the middle of the hall. Please give your PowerPoint presentation to the technicians which are located there. Now the technical session is going to start now for the day. That is technical session 4. Rural bio sewage treatment plant system technologies for recharging aquifers or recycling with reuse options for environmental management in rural areas. For this session, now the session chair is Dr. P. Lakshmana Perumala Swami and Dr. J. Brema. I request both of them to come the dais and occupy their chairs. I request all the authors, please give your presentation details to the technicians which are located there, please. The session is going to continue now. I request both the session chairs are requested to come and occupy the dais. Dr. P. Lakshmana Perumala Swami. I will give the brief introduction about sir also, and Dr. G. Brema. Please come and occupy the chairs, please. Sir. Yes, the next session. Because there's no. I thank the former session chairmen, Srinivas Reddy Saab and T. Srinivasan.
Yeah, both of us. Thanks a lot for bearing with us so much. Thanks a lot.
Thank you, Lord. Thank you, Lord. Now I will have a brief introduction about Dr. P. Lakshman Perumala Swami. Yes, sir. Yeah, please occupy the chair. Yeah. Please raise your hands because the authors who have come here, please, you have to hand over your PowerPoint presentation to the technicians which are located there. Just would like to know, Mr. Rajiv KN, he has come? Rajiv KN. Please raise your hands if he is here. Rajiv KN. Then Dr. Ravi Shankar? Yeah, please. Sir, please hand over your PPT. Fine, done. Then Avin M. Yes, sir, please. Please hand over your PPT. Fine, sir, fine. Then Raghav Kotabagi. Raghav Kotabagi, please. Whether he has come? Okay, fine. Then third, others. Then Meghana. Okay, you have given, no? Fine. Then Mohan K. Okay, sir, fine. Srinivasamurthy. I think he has not come. Anyway, sir, I think 4 or 5 people have come. You can start up with. I think the second paper, Dr. Ravi Shankar may start. Anyway, our session chairmen, they are going to invite you. Just I will try to tell more about the session chairs. Let us start with Dr. Lakshmana Perumala Swami. Presently, he is the mentor professor of Department of Environmental Studies, Bharatiya University, Coimbatore. He is postgraduated and doctoral program completed from Annamalai University and is served as a reader in Cochin University, Science and Technology. He was a professor of Department of Environmental Studies since 1987 to 2008 and is a registrar of the Karpagam University from 2008 to 2014. 2016 onwards, UGC appointed him as a emeritus professor. Currently, he is working as an emeritus professor at Bharatiya University. His field of research is environmental science, that is physically rainwater harvesting, and as I heard, in the campus covers almost nearly 800 acres, out of which here 2 lakhs plantation has been done in this campus, Bharatiya University campus, where now we are conducting the program. In this, almost 2 lakh trees were planted by under his leadership. I have to thank him and have a good clap, please. And they have constructed so many check dams, percolation tanks and all. Almost all the methods have been taken for the rainwater and harvesting and all. I thank him for, I request him to to chair the session, sir, please. Then over to Dr. Brema. 1 minute. I will start because he is a professor of in civil engineering, that is specifically in water resource engineering, working at the Carolina Institute of Technology. She did her BE and ME, MTech and postdoc, doctoral degree from same university, from which university, that is Anna University. She has got 25 years of experience and she has worked majorly in the field of GIS and its applications, water harvesting and all, and he has taught the undergraduate students and all. She has got a project from ISRO and several projects, and he has published almost 44 research papers, and 30 out of which 30 papers under from the reviewed journals and all. And currently she is guiding almost 6 doctoral students, and his biodata is very strong, and she has completed several projects. We have to thank him for gracing the occasion. Madam, I request you to chair the session along with Dr. Perumal Swami, sir, please. Please, I will hand over it to the session chairs to conduct the proceedings of the meeting, please. Yes, please.
Yeah. Thank you for a nice introduction. I think we are running behind schedule. We will start the session. May I request that across of people, missionaries, to have your presentation. You take 10 minutes, please.
Good afternoon, ladies and gentlemen. My name is Sanjay Moge, and I am from IWWA Machineries Private Limited. We are one of the largest manufacturers of submerged pumps. And we thank IWWA for giving us an opportunity to present pontoon-mounted submersible pumps, submerged pumps. And the subject for today is innovative pontoon-mounted submerged pump sets. So this is the pontoon. This is just a sketch, actually. And these are the photographs of pontoon as to how this can be mounted. And the main advantage of the pontoon is that you all might be aware during summer season, the source of water goes haywire, and there's a problem of water coming into the jet well. So there the pontoon comes into picture, and how it works, we will go through it maybe after some slides. So this is the walkway. We use flexible as well as MS pipes to carry the water. Now what is pontoon? Actually it's a floating structure made of MS, and it is designed to install submersible pumps, submerged pumps, and well balanced. Actually it is also approved by IRS and the Port Trust of India. Even IIT has also approved these pontoons in the projects which we have executed for the balancing purpose. Now, why pontoons are required for the pump sets? Actually, you all might be aware that building up a jet well for any project, it's a time-consuming job, and it would take around 3 to 4 years to build the jet well. So here the pontoon comes in picture, and it takes less time to manufacture pontoon as well as the pumps. Then it's very easy to move. It's a it's portable one, and it can be moved very easily. It saves the space because no civil work is required for it. Only the walkway, the flexible pipes, and the pontoon will be there. No heavy structure is required for this. And again, the advantages are the cost of the total project. You need not buy the raw material to build the jet well or the pumping station. Then there won't be any labors involved, because these pontoons we are manufacturing at our plant and dispatching along with the pump. So no labor cost will be involved at site. Our people will come, they will install, and it's a plug and play kind of thing. The major advantage is that no land acquisition is required. As we see for the jet well, all sort of documentation, then legal problems while land is acquired, all those problems will come here. So this is a very easy solution for the pumping. Now, which type of pumps are most suited for installation on the pontoon? Actually, on pontoon, you might see that some of the customers, they are going in for horizontal split casing pumps, vertical pumps, and submerged pumps. But the advantage with the submerged pump is that pontoon is well balanced when these submerged pumps are installed. The reason behind it is the gravity, it moves downwards. And in case of horizontal split case pumps or the vertical pumps, it is shifted upwards. So there is a danger of pontoon toppling. So this can be avoided in case if submerged pump is installed on the pontoon. Similarly, we have shown in these figures as to how the pump can, the pontoon can topple in case if vertical turbine or horizontal split case pumps are installed. Then why the submerged pumps are advantage as far as pontoon mounted pumping is concerned? So major advantage is that the submerged pump is a mono shaft pump. The motor and the pump, it's mounted on a single sturdy shaft as against of vertical turbine and horizontal split case pump where motor is coupled along with the pumps. So balancing is the problem, then vibration is another problem, then the problem of lubrication is there, maintenance problem is there. So best suited pump for the pontoon mounted application is submerged pump because both pump and motor will be submerged in the water. Then there is no roof is required. No roof is required for the submerged pump when it is mounted on the pontoon because both the pump and motor is submerged. As against for VT pump and the horizontal split case pump, you will have to go in for the roof because in case of rains, then there is a chance that motor may burn. Then because of this roof is not there, the weight of the pontoon is drastically reduced, and which leads to cost benefits. Then a lot of people say that what happens in case of debris will come. So all the submerged pumps are provided with the stainless steel strainers, which will avoid any foreign particle or the aquatic creatures to go inside the pump. So as we were discussing earlier, that for vertical turbine or the horizontal split case pump, there is a chance that pontoon can topple. So these are the figures we have shown how the gravity is shifting downward, center of gravity. Then in case of submerged pumps, these are weatherproof pumps. So no need of roof as we have discussed earlier. And the weight advantage while we go in for submerged pumps. No need of alignment. Actually, operation and maintenance is very easy for these submerged pumps because no maintenance is required because both pump and motor, they are submerged into the water. For vertical turbine pump, every now and then the person or the operator has to go there. He has to check whether lubrication is proper or not. He has to check whether alignment is correct or not. He has to see the vibrations are there or not. And this is applicable for both vertical turbine as well as for horizontal split casing pumps. So this is one of the photographs. Actually, we have executed a lot of projects where submerged pumps have been supplied on the pontoons. This is one of the projects which we executed for NTPC Kudgi, wherein actually they were facing a lot of problems with the contractor as the contractor was not able to build the jet well. 3 into 800 megawatt power plant for which raw water is supplied from Almaty, and the raw water requirement was required for commissioning of the new unit. So originally the project was along with the jet well, but unfortunately because of the water constraints, contractor, he could not build the jet well, and NTPC was in crisis as no water was there and they were not able to commission the project. So they had heard that IWWA has supplied pontoon mounted submerged pumps. So they got in touch with us And our team proactively, we went there, met NTPC officials, explained what can be done, we explained the solution, and they agreed. So we recommended them 3 number pumps of 600 HP with 1250 meter cube per hour at 100 meters head. And these were suitable for summer season as well as for the rainy season. And the difference of level was 13 meters. So during summer, actually they would take out the pump, and I'll show the figure here. You see this one. Actually, during summer season, they will take the pump out from the pontoon, they'll pump the water, and during rainy season, they will again mount these pumps on the pontoons. And this is how actually we were able to execute this project within 60 days. And the project was commissioned in time. These are few photographs. Actually, you can see the flexible pipe as well as MS pipe, then it's going in the common header, and the water is going to the plant. Here, during, sorry. Yeah. So during summer season, these pontoons are kept away, and pumps have been put in directly in the source. This is during the rainy seasons. And this is the certificate which NTPC they have issued. And to the delight of NTPC, actually, they were able to commission 800 megawatt power project because we supplied the pumps in time, within 60 days of time. This is one more project, MIDC Ranjangaon. Actually, same problem was there. The river, it changed the course, and they were in problem. The department was in problem because there was no water in the check well. So again, we visited site, we recommended them the pumps, and you can see the pipe, MS pipe there, and we installed a couple of pumps on the pontoons, and we started pumping. This pipe will go to the check well, and check well was being flooded with 2 number of pumps. And thereby, they were able to supply the water to MIDC. Now, this floating jetty or the pontoon, it is made of MS IS 2062 grade 250, and it is being tested as per standard ASME section 5, article 6. Our pontoons are approved and certified by IRS, IIT, and Port Trust of India for the balancing, because this approval is necessary, and they certify that the balancing is quite okay, and this can be used in the flowing river. So these are the few risks and advantages of pontoons. As we are discussing the MIDC Ranjangaon case, this is how the stream...
Sir, please sum up.
Yeah.
Please.
Yes. And this is how the pontoon works. Concrete anchor blocks of various sizes are lower in the bed, and the stability is given to the pontoons and the walkways. Then lifespan of these pontoons are around 20 years. This we have already discussed why submerged pumps we should go in for, and how those are advantageous while being mounted on the pontoon. These are some pros and cons. In case if somebody wants, we can give all these details to those who want this. These are all the performance certificates. Sorry. Again, we have executed one job at Power Grid Corporation, Nabinagar in Bihar. Same issue they were facing of the water, and 1000 meter cube, 70 meter head of 350 HP, 3 number pumps we have supplied. This is how the pontoon is commissioned. These are few photographs of Nabinagar Power Grid. These are the credential, some of the references of pontoons where we have supplied. So thank you so much. So in a nutshell, we can say that the submerged pumps are best suitable for the pontoon mounted operations. And in case if any questions are there, I'm ready to answer those.
Thank you for a nice presentation.
Thank you so much, sir. Thank you.
We wish you all the best.
Thank you, sir.
May I have the first speaker, Rajiv? Rajiv? May I call upon Ravi Shankar, Dr. Ravi Shankar? Please. Title of this paper is Sustainable Rural Bio-STP for open flow sewage in nallas in the absence of sewers, which is very common for recharging aquifers, reuse in agriculture, horticulture, a successful case study in Chennai. Please, sir.
Thanks very much to the chair. I'm Dr. Ravi Shankar. I'm former technical advisor to Bangalore Water Supply and Sewerage Board. Today I will be presenting a case study. I think the title has been mentioned by the chair already. Next slide, please. I think one of the next presenters will be presenting in detail. In Bangalore, water in any form, whether good or bad, is a resource. Now, there are very good case studies of reuse and recycle and reuse of water. In Bangalore, almost 850 ml of water, treated water, is pumped to the lakes all around the surrounding districts of Bangalore, like Kolar, Chikbalapur and all. Now, let us come to the case study, what I have been given, how to optimize the use of wastewater flowing in open drains for the beneficial purpose. Next slide, please. Yeah. In Bangalore, you can see water is being sold to many industries like golf club and then wheel and axle plant, Bharat Electronics Limited, BIAL, International Airport, and then almost 3,000 STPs in various apartments is also being recycled and reused. But all these things are the good case studies where there is presence of sewers and sewage is conveyed to the sewage treatment plant. And then we have a facility to treat, and all the technologies are available. So many options are available, so many designs are available, so many case studies are available. But there is a specific need in India, especially in the rural side, where sewers are not present, but sewage is available and flowing into open drains, through open drains to the nearby lakes or any river or water body. There is no specific case study of taking directly water into a treatment plant from an open nalla. Now, how to optimize, how to do this is a case study. Now, everybody knows upflow anaerobic sled blanket reactor, where the water is allowed to flow from bottom to top, and then top, that's the simple technology where the wastewater is moving from bottom to top and collect using anaerobic technology, and you get the biogas as a byproduct, and the output of the water will have less than 70% of BOD removal. And maybe if you have 300 BOD, you will get 100 BOD in the outlet without any energy, and you will get energy in the form of biogas also. So this is one thing which we can think of using to reduce the power consumption and also get the uniform quality of water to the next reactor, that is aerobic reactor, because this will not meet the reuse standards of the government, whatever it has been fixed. Now, this is what you can say is a special case study. Whatever I showed you in the previous slide, there is a funnel on the top. The same funnel you can see in this slide, where it is a stainless steel funnel, where you get the biogas out of that one. And without any energy, we can remove almost 70% of pollution. Now, another modification is, if you have any blowers and diffusers in any technology, though it is so nice and proven, but it costs, its power costs and its maintenance costs, diffusers maintenance costs adds to the problem. So I have revised this. You can see I've taken the water effluent of the UASP and broken it into droplets using a submersible pump. There is no blower or no diffuser, and the water drops on a plastic media. It's called as biodeck, and you have a fixed media system. So this is a closed system. This is a closed system. Only for the video purpose I have taken this. You don't have blowers or diffuser. I am making the technicality or the innovation. Instead of a bubble going in an aeration tank from the bottom of the tank to the top of the tank and oxygen transfer, I broke the water using a nozzle, and it's a specially designed nozzle. And then air is supplied through a simple fan. That's all. It's a closed reactor, and any aerobic reaction, as you know, heat is a byproduct. So heat is contained, and temperature of the reactor will be more. Naturally, biodegradation is also be faster. Now, this is a case study which I wanted to present. This is in Chennai middle. It's a multi-tower complex that's under construction. Now, there is a nalla, open nalla that is flowing. Just like that everybody knows in Chennai, it's a Kuvam river, or that's a Oteri Nalla, okay? That is very next to that complex I showed you. Now, I took the raw sample, a grab sample in the Nalla. The BOD is 96 mg per liter, COD is 276, TSS is 408, ammonical nitrogen 29.4, and oil and grease around 10 milligrams per liter. This is the raw sewage water. Now, what I did is, I inserted two submersible pumps, one working and one standby. In the Nalla, you can see two, that is RCC, what we call as RCC rings, and such that the floating impurities will not go there, because the holes in the ring is in the opposite to the direction of the flow of water. That is taken to a degreating chamber from there. From degreating chamber, I have taken two UASB reactors in series, and then it goes to the next biotowers by gravity, and then we have a recycling facility. Then we have everything is portable. So because once the project is complete, this can be shifted to anywhere. Only thing innovation is what I told you in the previous slides. They use anaerobic technology and aerobic technology, no blowers and no diffusers. Use syntax tanks for settling and the tertiary treatment. We have filters also. So this project, you can see another close-up view. We have a sand filter and carbon filter also. Now this water, this is a close-up view of the sand filter and carbon filter. So it's a tertiary treatment plant. You can see a batching plant very next to that one for the construction purpose. Now this is taken to batching plant, and then this is the standards required for construction purpose as per IS 456. It meets that standard. Now, the production cost for tertiary treatment is around 18 rupees per KL, whereas they were purchasing the tanker waters at 120 rupees per KL. Now, this is how they could save the water, the cost. Now, This is the quality of water. One cannot imagine whatever the black water that flows in the open nalla, the same water becomes like this in limited time. This is not that we can do similar things using syntax tanks also. Same concept, same anaerobic reactor, then aerobic reactor, and then we have settler, filtrified, everything, and we can do it in a small, this is about 5 KL treatment plant in an apartment. So that means it can be scaled up or scaled down, the technology. This is 1 MLD plant and the similar technology in the Sri Perambur technology. You can see the treatment plant, everything is closed. You can see the top of the treatment plant looks like this. You can do a function on the top, there's no odor. And this is the front elevation. You can see the water, how it looks after treatment. This is being used for toilet flushing and gardening in the entire campus. This project is for the Apple phones manufacturing unit, Sri Perambur. The production cost is around 9 rupees per KL. Against generally it is 30-40 rupees because majority of the pollution is removed in the aerobic technology. Now this is similarly, the community also produces food waste also. You can see the food waste and also can be grinded and made it into the liquid waste, and then the gas can be used for the, you can see the lady is putting food waste into the grinder. It's just nothing but a big mixie. You get biogas. The excess biogas, if you don't want, you can flare it also. That means food waste is, by grinding, you are converting it into liquid waste and treat it similarly, like what I showed you. It is possible to do. This is another treatment plant in Bangalore in AMC Engineering College. Left side is the hostel, right side is the teaching facility. In between, you have a sewage treatment plant, which is closed, and the gas is being used, stored in a gas balloon, and is being used in the kitchen for making vadas and other things. That's a photo. So this is the biogas. If it is not used, it is flared to avoid a greenhouse effect. Now this is the quality of the gas. I will not go detail into that one, whatever the gas you are. This is another treatment plant on the same technology. We are done for Bangalore Club in Bangalore, facing Richmond Circle, nobody knows it's a treatment plant. On same technology, we are done for 300 KLD for Bosch campus in Germany, in Adgodi. Results, everything top is closed. No blowers, no diffusers. So what we can conclude from here is that it is possible to take, in the absence of sewers also, in any case. So in India, many sewers, many villages or even taluk headquarters will not have sewers. The sewage will be flowing in open drain and finding way into water bodies. Why can't we take directly and then treat it? Every problem has a solution. This solves the, see, in many cases, especially in Karnataka Urban Water Board, doing many projects, they put the sewers. Unfortunately, nobody will take connection, or even the flow is so less, it will not treat the treatment plant also. So always it finds way into the water bodies. So we can, in the absence of sewers, there's no good case study in India where we can take water directly. So everybody thinks it's very difficult to treat the open flow sewage. Actually, I was lucky enough to get this project because when I went to MOU meeting along with the owner of that project. So we were waiting in a waiting hall. The owner was telling, see, very next to my project, so much of open for sewage is there, everything going waste. Is it possible to treat this? So there was no case study. He said, based on my experience in my water board, and I was telling him about 40 years I'm in the same field. I asked him, give me a chance, I will try. So I was fortunate to get the opportunity to get this project done. And now they are using it for gardening and even for construction purpose. The one problem here is there will not be, in case of major cities, consistent quality of the water will not be there in an open nalla. But in case of villages and taluk headquarters, it is not a problem because you will get usually uniform quality of raw sewage quality. So definitely you will get, it's sustainable, we can do it. And once the project is complete, once the sewers are laid, we can always shift that project to somewhere else. So it can be done for any KLD. I showed you the case study of 3 KLD to 5 KLD to 1 MLD. Now we're doing 3 MLD plant also. It can be scaled to any size. So any project will be successful if and only if it can be scalable and replicable. So it is scalable, it is replicable, And majority of pollution is being removed by anaerobic technology. It's an engineered process, so we can do whatever we want, whatever the size we want. Only thing we have, we should always think positive. We should always think, learn from success, copy the success and learn from the failures. This, which is not happening in many case studies. See, we show success plans, but we don't learn from the failures. So what I have done is, in my last 40 years of experience in Bangalore Water Supply and Sewer Board, and after coming out of the government, I did so many tech consultancy works like this, and many of the projects are working nice. With this background, I close my presentation. Thank you.
Thank you, Dr. Ravi Shankar. Any questions from the audience side? Any questions? Yes.
Very good question. Anaerobic technology is the one which gives, you cannot use anaerobic technology to the reuse standards. It should be, your combination should be anaerobic plus aerobic, because anaerobic will remove major pollution and also give you a end product of biogas. We can use it for that one, but that will not meet the reuse standards. Now, from that, you have to take that water and further subject to treatment like aerobic technology. Aerobic technology, there are so many. We have, previous presenter was telling, like SBR, MBBR, active test-led process, rotating biological contactor, so many modifications of those things are available. So if you have anaerobic reactor, which is UASP, which is vertical in nature, so the output can go to aerobic reactor by gravity. That is the advantage. That's why I have taken that as a, I got for this technology the first award from the Confederation of Indian Industries and FICCI also, and All India competition also I got national award for this one. It is easily maintained. So if you don't have blowers and diffusers in any technology, half the problem is solved. One is noise, other is power, other is maintenance. I have seen case studies in an apartment. The people doesn't allow to run the STP because of the blowers. Though the quality is good, everything is good. The residents just above the STP apartment, they don't allow us to run the plant. What to do? So they have to sleep. So those people are coming to our, as a consultant, we are doing problems, solving those problems also. So any sewage treatment plant is an asset, but if it is maintained properly and meets the social requirements, you should not produce the odor. So because my system is a closed system, if it is odor, I can collect the odor and scrub it using water and remix it with chlorine. So that water will be, so you know, hydrogen sulfide is the main cause for the odor. Hydrogen sulfide readily dissolves in water. Now, at the same time, you can add chlorine also. It oxidizes the odor in the water. The same can be recycled. We have case study. We are done it for Kriya University, very near to Chennai, where we have a facility to scrub the odor also. Depending on the case to case, if the bioreactor is closed, we can do wonders. We can do, we can engineer all the requirements where the society problems are being faced.
Okay, sir. Is it a grey water or black water, sir?
No, black water only.
Black water.
Open Nala is black water, everybody knows. But several case studies we have done for normal domestic sewage.
Thank you very much, sir. Thank you for your presentation. Thank you.
That's a seeding purpose. Yes, yes. Because grey water will not have much BOD.
Yes.
So if you had to develop microorganisms in a grey water, because it has got most of it is soap. In grey water, you take from the, some people take kitchen waste water also out, where you use a lot of detergents to wash the utensils. And also the washing machine water also comes there. And the soap water which we take bathing also comes there. At such times, if you want bacteria to grow, cultures are available. People use jaggery as a medium because it adds some POD. So,
thank you, sir.
Like that.
Thank you very much. You can have a discussion during your lunchtime, please.
One question is last, only one person. Yeah. Recharging of? Yeah, correct. See, that's what I was telling you in the first problem. In Bangalore, 850 ml of recycled water, that is treated water, is sent into the lakes all around Bangalore. I think one of the presenters will be doing that presentation next from Tata Consulting Engineer. 850 million liters is being reused indirectly by recharging aquifer through lakes. That's the next case study. You will get the answer for that.
Thank you, sir. Thank you very much. We have got more papers.
Thank you. Thanks a lot.
Thank you very much. May I call upon next speaker, Avin Yam. Please. Avin Yam, GVK Mohan. Anybody else? Oh, all the three are there. SM Karthikeshwaran. Yes.
Good afternoon to all. My name is Karthikeshwaran. I'm from Tata Consulting Engineers. My colleagues Avin and GVK Mohan are here. Can we go to the next slide? So today's presentation is about recycle and reuse of treated water and byproduct utilization at 150 MLD sewage treatment plant at KNC Valley, Bangalore. In this presentation, we'll be covering about the project background, the key features of the project, the process flow diagram, the sewage quality and the effluent water quality, power generation and reuse of the treated water, and the benefits of this project. Regarding the project background, the sewage treatment plant is located in the state of Karnataka. This is located at KNC Valley, and this plant is commissioned by BWSSB. This location is located at a cluster of STPs are there. One of the STP is 150 MLD capacity. TC is the project management consultant for this project. The main objective of this project is to meet the treated water quality, to meet the NGT guidelines and the Karnataka State Pollution Control Board's discharge standards. In other associated benefits are the byproducts which are getting generated from the STP like biogas, and the sludge are getting reused. The project was funded by the government of Karnataka. Okay, the key features of this project. The technology adopted for this project is biological nutrient removal, that is removal of total phosphorus and total nitrogen. Then for sludge treatment, to achieve Class B US EPA guidelines, 20 lakh MPN per gram of total dry solids was one of the key feature of this project. then to achieve the total suspended solids less than 10 milligram per liter, tertiary treatment technology was adopted. The byproducts which are getting generated from this STP, namely the treated water, the biogas, and the sludge, are getting fully utilized. This is the process flow diagram of 150 MLD Keynes Valley. The sewage is coming from ISPS, which is located at Koramangala Sport Complex. The mechanical screens are used for removing the solid particles, and here after the screen sewage is then led by gravity to vertex type grid chamber. From there it passes by gravity to primary clarifier, where about 35% of BOD and 60% of the inlet TSS is getting reduced. And from the outlet of the primary clarifier is then passed through anaerobic A2O process. Anaerobic zone, anoxic zone, and aeration zone is there in single structure. The treated water is then passed through the secondary clarifier and the tertiary treatment disc cloth filter, and then chlorine contact tank by gas chlorination for disinfection and reuse. This slide talks about the sludge treatment. The sludge which are getting generated from the primary clarifier and secondary clarifier are combined in a thickener distribution structure, and then it is passed through the thickener, where the sludge consistency is increased to about 2%, and then it is collected in the sludge sump, and from there it is pumped to the anaerobic digesters. 4 number of anaerobic digesters are there. These are high rate anaerobic digesters, and followed by sludge cum biogas storage tank. The sludge that is settled at the bottom of the sludge storage tank is then pumped to the centrifuge for getting a sludge consistency of 25%. This slide talks about the A2O process. This process is adopted to prevent eutrophication of the lake, and also additional benefit is energy reduction. A2O process leads to reduction of pollutant load and further tertiary treatment process also. The mixed liquor recycle ratio that is adopted is 500%. The return RAS ratio is 68%. The hydraulic retention time of the anaerobic zone, which is used for sizing the anaerobic zone, is 1.5 hours. Anoxic zone, likewise, it is 3.6 hours, and the aerobic zone 7.6 hours. This slide talks about the raw sewage quality, which is used for designing this plant. The pH of the raw sewage 5.5 to 9 is getting reduced to 6.5 to 9. BOD 350 milligram per liter has to be reduced to 10 milligram per liter as per the NGT guidelines and KSPHB standards. COD from 800 to 50 milligram per liter. Likewise, TSS is from 450 milligram per liter to less than 10 milligram per liter. The total nitrogen inlet value is 70 milligram per liter, and which has to be reduced to less than 10 milligram per liter. The total phosphorus is 7 milligram per liter at the inlet, and at the outlet we have to maintain 1 milligram per liter. Likewise, fecal coliform must be less than 100 milligram, 100 mpn per 100 ml. This slide talks about the sludge quality. The type of sludge is anaerobically digested, dewatered sludge. The sludge class that is to be maintained is less than 20 lakh mpn per gram of total dry solids. At the outlet of the centrifuge, maximum sludge VSS TSS ratio to be maintained is 70 milligram per liter, and minimum sludge consistency at the outlet of centrifuge to be maintained is 25%. This slide is about the plant layout. So in this project, as the previous speaker was telling, one of the major source of major power consumption is through blowers. So in this project, we are adopting centrifugal type blowers compared to the PD type blowers. The advantages of this type of blower is it consumes lesser energy comparatively, and due to which lesser O&M cost is there. And there is a lesser, this type of blowers will occupy lesser area, and the comparatively lesser noise reduction is also there. As you can see, acoustic enclosures is there in this blowers. From the anaerobic digesters, biogas is getting generated. So that biogas is utilized for generating power. Power from the utility grid is basically the primary source. The additional source is from the biogas engines. So if you see, we could achieve 60% reduction from the, about 60% reduction from the total plant requirement, power requirement. This slide talks about the estimated cost savings due to power generation by gas engines. So around 80 lakhs per month can be saved, and that BESCOM, the utility power can be utilized for other purposes. This is the gas engine of 1414 kilowatt. Two numbers of gas engines are there. This is one of them. The treated water which is coming out of this plant, 150 MLD, is completely pumped to Kolar lakes for artificial groundwater recharge. That 150 MLD STP you can see. Apart from that, other STPs are also there. This is one of the STP where 150 MLD capacity is pumped to the lakes in Kolar. These are some of the site photographs. At the left side you can see disc filters, and the right side there are vortex grid chamber, and at this side these are anaerobic digesters. The right corner. The major benefits of this project is the complete use of the treated water which are getting generated, and due to which the reduction in energy consumption is also there. Because of reduction in energy consumption, there is a reduction in the O&M cost also. And also there is a reduction in the carbon emissions and climate change reduction. So ultimately, this project is sustainable in nature. Thank you.
Thank you for a nice presentation. Any questions from the audience side?
Sir, yeah, there are many other technologies like UV, ozonation, gas chlorination. So it's not depending upon the techno-commercial feasibility. This was selected, and there is UV can also be adopted.
Okay. Thank you.
One more thing is, now if you are using UV, now if you might have seen it at the treated water quality, we have to maintain less than 1 milligram per liter. So for that, we have to, again, we may need chlorination, residual chlorine, to maintain residual chlorine, less than 1 milligram per liter, because it is used for reuse. It's getting pumped to, through pumping station, it is getting pumped to Kolar. So residual chlorine minimum level of less than 1 milligram per liter has to be maintained. So that is also there.
Yeah, when it comes to reuse, I 100% agree with you. When it is for disposal, like these days, chlorine, the byproducts like trihalomethanes, which causes cancer. So when you go for disposal, will you be able to segregate UV treatment against chlorine? Is that possible?
Yeah. Depending upon the end use, the technology can be, suitable technology can be adopted. Here in this case, is for reuse, and less than 1 milligram per liter also to be maintained. That will have a additional infrastructure requirement other than UV. So that's why this was adopted in this project.
Thank you, sir. Thank you.
Thank you.
Any other questions? Yes, sir.
It may clog the surface of soil for reuse of recharging aquifer. So what will be the frequency of cleaning of that surface, or that is not required?
Sir, less than 10 milligram per liter of, I think you are talking about TSS, less than 10 milligram per liter of TSS. So less than 10 milligram per liter of TSS is a very lesser value. So that will not typically result in such a huge amount of settlement. So what I can understand, like this filter which is proposed here, the tertiary treatment, that is proposed for reducing the TSS from 30 milligram per liter to 10 milligram per liter. So because of that 10 milligram per liter, I'm saying it's not a big, that much settlement won't be happening. Yes.
Please use the mic, sir.
My question is only whether it is required or not.
It's not, additional treatment is not required.
You are using reuse as a recharging of aquifer.
Yeah.
So it may disrupt in the long run or not.
These are all very, very fine particles, very fine particles. So this will get over a period of time, it will take a long time for that accumulation. And these are all series of lakes are there. They will be, I hope I've clarified your question.
Okay, any other questions? Now, when MPN value 20 lakhs per, my question is?
Yeah. Yes, sir.
My question is, MPN value per gram of soil is about 20 lakhs. don't you think it is a more number? Will it not, when you use this to the soil, apply to the soil, will it not affect the soil system?
This value which you are trying for soil. Sir, currently there are no standards in India for
you can
for
think
sludge.
over. You can think over 20 lakh will not be there. It will be affect that system,
Yes,
soil
yes,
system.
yes. Now
You
class
try-
A sludge is getting adopted.
You try to reduce it.
Yes.
Okay.
Yes.
Okay, thank you very much for your nice presentation.
Thank you, sir. Thank you all.
May I call upon the next speaker, Raghav Kotabage. Please. The title of the paper is Closing the Nutrient Loop Through an FSTP, a case of Badagabettu.
Very good afternoon, everyone. So, myself Mohan, I am associated with CDD India, which is an NGO located in Bangalore. So, my topic is closing the nutrient loop through an FSTP, a case of Badagabettu, a Gram Panchayat in Karnataka. So, yeah, so to give a glimpse about who we are and what we do, CDD stands for Consortium for DWATS Dissemination. Again, DWATS is Decentralized Wastewater Treatment System. So we are headquartered in Bangalore. Our aim is to innovate, demonstrate, mainstream inclusive water and sanitation solutions by developing contextualized, decentralized, and resilient nature-based solutions. Having said this, we are working on many sectors, starting from used water management, not wastewater management, that's the terminology that we use, fecal sludge management, water body rejuvenation projects. I'm very proud to say that we are also partnered with Smart City Coimbatore proposal for 8 lakes rejuvenation in Coimbatore again. So we also deal with solid waste management, urban resilient projects, water security projects. So my colleague Meghna will provide some of the brochures about CDD and some of our sectors. You can please go through and then reach out to us for any kind of services required along the line that we work on. So, so again, the fecal sludge is human shit everywhere that we defecate. So in India, if we talk about the agricultural, so the major India's backbone is agriculture. Indian economy's backbone is agricultural. So about 70% of Indian population engaged in agricultural activities. So as Dr. Geeta Lakshmi ma'am also said yesterday that to do agricultural activities, we need about 80% of water requirement. So 80% is not small. And then, 3-4 decades before, there was a huge quantum of water availability in the form of open well, in the form of water bodies, and some other or various other water resources. So over the years, over the decades, the more we become urbanized, we started using the borehole system, from which we are started extracting more and more water without any limitation, though the government is trying to set the limitation. So what to do now? So either you have to stop the agricultural or should look for alternative approaches to reuse the water for agricultural activities. So what's the alternative that available in the country is the precious used water that we generate every day. So treatment of used water can cater the needs of agricultural activities, not only agricultural activities, but various other reuse activities as well. So one such approach is fecal sludge treatment plant that we have. So again, the fecal sludge treatment plant or fecal sludge management refers to safe containment, collection, transportation, treatment, and then safe reuse or disposal. So from the the pit latrines or from the septic tanks or from some other on-site sanitation systems from which we desludge it. So through SBM, the government has ensured that all the households will have user interface in the form of basically the toilet cubicle. Also the safe containment. So it is not a holistic approach, right? So you have the user interface, you have the containment, you are defecating, you are storing it in a containment. So what is next? So it is seeping through the groundwater or seeping through the ground and contaminating the groundwater. So how do we ensure that a holistic approach can be followed for this? So again, so once the containment fills, what do we need to do? So we have to desludge it. So government also has initiated to have every town municipality to have such desludging trucks. So once it is desludged, where it can be disposed? So the government said that they can be disposed in STPs or it can be co-treated with STPs. But is it really happening? That's the question. So as you can see in the pictures, in majority cases, especially in the context of rural, whatever desludged from the containments is being disposed in the open water bodies or open drains or open nalas or in the open lands, which is not environmentally sustainable or environmentally, very unhygienic to the environment. So this is the abstract that we have written, which I have explained. So I can briefly explain about the project. So Badagavuttu is a Gram Panchayat located in Udupi district, Karnataka. So it has population range of about 8,000 to 10,000, including the cluster villages, it is about 30,000, 40,000 population. So they were not having any designated treatment unit to manage the fecal sludge, as whatever the desludge that was desludged from the sludge that was desludged from the containment has to travel for long distance to the town municipality where the treatment system is exist. So as it is not profitable for the truckers as well, they are disposing in the open lands and then leaving it as it is. So yeah, so as I said, it's fine. So what is the approach that we have followed? So you know the problems. So what is the approach in which you can understand the situation assessment or existing assessment, and then what can be or what interventions can be adopted? So we have developed a comprehensive liquid waste assessment by visiting the Gram Panchayat, visiting each household and then understand whether do they have the user interface, do they have the containment, what type of containment they have, and then water supply, various other data collection that we had done. And then the project majorly focused on efficiently managing the fecal sludge emptied from the OSS, as I said. And also the project aimed at generating the revenue through the generation and sale of bioproduct, the nutrient biosolids from the fecal sludge, and then the the treated wastewater or used water. Additionally, the plan emphasized the reuse application of the treated nutrient-enriched rich compost with the aim of closing the nutrient loop, as it is not currently a holistic approach. So the objective of treatment majorly to remove the pathogen removal, organic load reduction, the BOD, COD load reduction, and then reuse of the byproducts. At the same time, the treatment should be cost effective, affordable. It should be affordable. It should be replicable in various other locations as well. And then should be low space constraint, low space requirement, ease of construction, which you can read through in this. So, getting into the quality of fecal sludge. So BOD, COD, so as wastewater is completely different from the fecal sludge holds a lot of organic concentration with the total solids percentage of varies from 20,000, 30,000, 40,000 mg per liter of BOD, whereas the wastewater has very less BOD, COD values. So quantification. So how we have quantified the fecal sludge for that particular Gram Panchayat. So we have followed 3 methods. One is population method, understand the population number, use different arithmetic, incremental methods, and then understand how much fecal sludge generation happens in a day. The other method, volume-based or containment-based method. So understanding the containment sizes, what type of containment it is, whether it is pitlet, the single pit, twin pit type.
Better you can concentrate your results.
Sure, sir.
Yeah, please.
Yeah.
Time is running out.
Sure, sir. Sure. So various methods are available to quantify the fecal sludge. One such method, which is very realistic, is collection method. Understanding the collection, how much collection is happening in a day in that particular Gram Panchayat, including the cluster villages. So based on that, we have understood about 3 KLD of fecal sludge is being desludged every day. So the treatment modules which are adopted are these. The pre-treatment, of course, the screen arrangement that we have provided. The sludge stabilization. So anaerobic stabilization reactor we have provided, as we also noticed that some of the fresh sludge also enters from the commercial units to the treatment unit. So dewatering, the SDBs, sludge drying bed or unplanted drying beds. Liquid waste management, DWATS, decentralized wastewater treatment system again, so under which there are many components in it. So we have used sedimentation tank or a settler along with anaerobic filter module. So post-treatment, we are having a collection tank from which the users can reuse the water, especially the liquid. It can also be provided or put it into the percolation pit or soak pit, which can be helped in recharging the groundwater. So this is the process flow of treatment system. The truck comes into our treatment system and it dumps into our screening arrangement where the initial screening happens, and then it enters into our anaerobic stabilization reactor followed by a sludge drying bed. The sludge part is taken care in sludge drying bed, and then the liquid part taken care into our integrated settler and anaerobic filter. So followed by that, we also have a tertiary treatment in the form of planted gravel filter, in which different size of gravels and type of plants are introduced for better efficient removal. Suppose that, as I said, we have the collection tank and percolation pit. Okay, so after the commissioning, so it takes about 2 to 3 months time for the treatment system to function at its efficient manner. So post that, we have understood, we have taken the the samples of liquid and solids, and then it is displayed here as well. So we have the treated water quality BOD, COD values are indicated in this, which are less than 30. The COD values are less than 100. Again, it is not really meeting the standards. We are trying to address what are the post-treatment activities can be adopted in this in order to reach the standards which are set by NGT. So whereas the biosolids parameters also listed in this. So overall, I would say fecal sludge treatment plant is required in cases where we don't have UGD connections. So UGD connections, again, it's cost intensive, time intensive, operational intensive. So having such fecal sludge treatment plants at rural level, wherever this again the UGD is not there. So wood again would suffice the treatment standards. So again the liquid part can be reused. The solid is being given to the agricultures for to use as a soil conditioner. That's it. Thank you.
Thank you, Mohan. Any questions? If there are no questions, we thank that author for his nice presentation. Next speaker is Meghana P. Meghana P, U. Anandamurthy, and Rohini Pradeep. Title of the paper is Enhancing the Nutrient Removal Efficiency in Constructed Wetlands Using Construction and Demolition Waste for Anaerobically Treated Wastewater. You have very brief introduction, then you go to your results. Okay?
So, good afternoon all. I am Meghna and I am working in for CDD since 10 months. So, I'm here to present one of my presentation, which is enhancing the nutrient removal efficiency using construction demolition waste for anaerobically treated wastewater. So here we can see few key terms which are like nutrient, construction demolition waste, and anaerobically treated wastewater. When it comes to anaerobically treated wastewater, it is treated throughout without aeration. There will be no air interference in the treatment. So, wastewater contains a number of pollutants in which it might include COD, BOD, nutrients, and these all comes from the human activities, especially nutrients, which is especially like phosphorus and nitrogen. These are mostly from human activities. It might be from the detergents which we use, from the feces, from the food, and a number of things. So, from a study, it is given that these nutrients in the wastewater varies in the concentration of 35 to 100 milligram per liter of total nitrogen and 18 to 29 milligram per liter of total phosphorus. If these nutrients are not treated in a treatment plant, and when this treated water joins the water body, it leads to the eutrophication and might cause to the death of aquatic species. And for this problem, the solution, the nature-based solution which can be adopted is a constructed wetland. When it comes to the constructed wetland, we know that kind of substrate is being used, and also few plants have been introduced into the system to treat the wastewater. So the conventional material which we use is gravel. Most probably gravel we use. This gravel is good in reducing the nutrient content, but good in reducing the organic content, but not the nutrient content. So when the nutrients reaches the water body, it comes in contact with the sunlight and might lead to the algal bloom or growth of phytoplankton, and might lead to the death of aquatic animals. So the methodology goes like this. First, identification of the materials, substrate materials which can be used as an alternate material for gravel, and then identifying the plants which gives good efficiency, and then checking for the efficiency for different materials. then fabrication of lab scale wetland and operating the wetland for different flow rates and different flow patterns, and then analyzing the samples and evaluating the results. So first, these materials, construction demolition based, these materials were analyzed for its removal efficiency. These were broken into the pieces of small pieces of 20 to 40 mm, and these were immersed in fresh water for 2 days and wastewater for 4 days in order to get adjusted to that environment. And then the wastewater from the vertical filter. So I forgot to say about a thing like vertical filter. From this anaerobic secondary treatment, the wastewater is getting partially aerobically treated through vertical filter. That water was used for the treatment here. And all these materials, materials which were used was fly ash brick, cement brick, and mud bricks. These 3 materials were put in a container and were immersed in the wastewater. And the samples were collected for different time intervals like 3 hours, 4 hours, and 5 hours. These are the pictures. So when it comes to the analysis results, it was found that fly ash brick was giving good efficiency at 5 hours retention time, which was like phosphorus removal efficiency was nearly 40%, and nitrogen removal efficiency was nearly 60%. So in this nitrogen and phosphorus removal takes place in different stages. When it comes to the nitrogen, removal takes place in 2 stages, which is nitrification and denitrification. In nitrification, it need oxygen to convert nitrogen, ammonical nitrogen into nitrates and nitrites. And then in denitrification, bacteria needs carbon source in order to convert nitrates and nitrites into the nitrogen. Here nitrogen gets removed from the wastewater. And when it comes to the phosphorus, phosphorus removal also requires bacteria. Again, bacteria requires oxygen in order to remove the phosphorus. So as this is an anaerobical treatment, no oxygen is being supplied there. That is why phosphorus removal was not taking place. In order to do that, this fly ash brick contain few chemical elements in it, which is like calcium, magnesium, and iron. These, due to presence of these materials, phosphorus was getting precipitated and getting absorbed on the surface of the fly ash bricks. So these are the fly ash brick results, which was giving to ammonical nitrogen was removed for 79%, and phosphates for 50%. And for this fly ash brick, in order to put it into a large scale, we have to check for the stability of the material, whether it disintegrates or no. So the stability of the material was checked by immersing it in the wastewater, in the water for 24 hours, and then agitating it continuously for 1 to 2 hours. And the results were these. So the initially it was weighed, and then this process was done, and after that it was oven dried and again weighed. The loose of the material was for 5.47 grams and 2.88 grams for the second cycle. So as the cycle goes on, the disintegration of the particles also reduces. And for the design of the wetland, which is a lab scale wetland, these were the parameters considered, like a HRT of 5 hours, flow rate, different flow rates of 0.5, 1, and 1.5 liter per minute. It was done in a tidal flow pattern. Void ratio between the material was 0.7, 0.39. Dimensions of the container was 0.3 meter dia and 6.2 meter depth. Specific surface area of the fly ash brick was 19.72. So this was the setup which was made. And the operation, after the wetland was fabricated, it was flooded with, initially with fresh water and then with wastewater. After 2 weeks, feed was given to the constructed wetland, which was in tidal flow pattern. and the flow rates were maintained for 0.5, 1, and 2 liter per minute. And then the samples were collected and was analyzed. So this was done for tidal flow and also for the continuous flow. These are the results. The blue color one indicate the tidal flow and the orange one indicate continuous flow. As we can see, tidal flow is giving more efficiency when compared to the continuous flow. So the results were like this after the treatment. Ammonical nitrogen got reduced to 69%, 51%, and 19% respectively for flow rates 0.5, 1, and 1.5, and phosphates for 35.29, 33, and 37%. And the results are if we consider the feeding pattern in comparison of two different treatment conditions like continuous flow and tidal flow. Tidal flow condition was giving good removal efficiency because it was also a system was supplied with proper oxygen while tidal system. When the water comes and flows out, there will be certain time where the oxygen can again accumulate into the system and then it can get treated. And also due to the batch flow operation, and in the continuous flow condition, on the other hand, displayed a reduced retention and also resulted of failed to show a substantial improvement in the removal efficiency. The consistency and the steady flow in continuous conditions reduce the interaction time between the wastewater and the treatment devices. Treatment reduces the efficiency. Effect of flow rate on the system. So the efficiency of the nutrient removal showed a pattern with which the better efficiency achieved in lower flow rates for tidal flow system, and the reduced flow rate most likely prompted perfect conditions for nitrogen and phosphorus removal. The organic reduction, on the other hand, demonstrated opposing behavior with greater flow rate exhibiting improved performance. The observed flow rate dependencies in nutrient removal and organic reduction highlight the complexities of wastewater treatment. And also flow rate optimization appears to be a most important thing while considering this type of pattern. Along with this, the plant growth was also monitored. Plant height was measured daily in order to monitor the growth. So first week, few shoots were dried up and the plant growth was not observed. When subsequently it was like 3 to 4 centimeters growth. And the thing which was observed was near the inlet there was no much growth. And by this, what I'll conclude is, so due to the precipitation adsorption mechanism, phosphate in the wastewater is getting reduced when fly ash brick is used as a substrate. And by giving the tidal flow pattern, good nutrient removal efficiency is being achieved. Organic removal is also getting achieved. Other than all these, leaching of calcium is being observed in the wastewater because fly ash bricks contains of calcium which might leach, and also pH was increasing due to this reason. And the way forward would be trials has to be conducted to optimize the flow rate in order to achieve both organic and nutrient removal. The long-term stability of fly ash bricks has to be monitored. And then N removal for fly ash brick was not observed more. So it was getting converted to nitrates and nitrites, but not complete removal of N. So some carbon source has to be combined with this fly ash bricks and has to be checked for efficiency. These are references. Thank you.
Thank you very much for your nice presentation. Any questions from the audience side? Any questions? Thank you.
Thank you.
What will happen to your material after use? Yeah. Where will you throw your material after absorption? Now, what is the efficiency that you have to work out? Okay? Replacement of material, and how efficiency this one? How many liters it can go for it? After that, what will you do?
That's what, sir. We have to check for the stability. That was my way forward. But material stability was increasing. Like, initially, when it was broken into pieces, pieces attached, that small disintegrated particles attached to the surface was getting disintegrated. And later on, when it was absorbed for 2 to 3 days, disintegration was low.
Okay. Thank you very much. We have one more paper. Mr. Mohan, Aparna Unni and Rohini Pradeep. Nature-based solutions to tackle the last mile connectivity issue of grey water management in metro cities.
So I understand we all are hungry. I don't have many slides. I have about 8-9 slides, which I'll quickly finish it off. Presentation, please. So this is our topic. So basically, how do we provide the safe sanitation to low-income, informal settlements in urban context? So this is as simple as it says. Again, the approach is nature-based solution. So just to give a background about this project, a state government has initiated a project, a drain rejuvenation project, the drain name called K100. Again, the K indicates Koramangala Valley or Koramangala Chalaghatta Valley, drain, or a particular valley. So in Bangalore, there are 4-5 valleys based on its topography. So Koramangala Valley is in the center of city. So it has about a number of drains, and then it has different names as well. So one of the drain is called K100, which runs in the city center and then for the about of 12 kilometers. So it was in a good condition about 30-40 years before. So that's what we also understood during our studies. So over the years, it has become an open sewer network. So as the city more become urbanized, so all the wastewater from the different commercial units, different households, from the industries, everything entered into this open drain as it is located at the lowest elevation. So it has about 32 square kilometers catchment area, and then it starts or originates near the Majestic, a location called Shantala Silks, and then essentially ends or joins at Bellandur Lake, which is again an open sewer lake, I would say, in Bangalore. The government is taking initiatives to do the rejuvenation of the same. So, yes, because of the rampant urbanization, because of solid waste entrance, wastewater entrance, industrial wastewater again, so it has deteriorated completely. So government has initiated this project, the project name called Citizens Waterway Project. So under this project, they have started doing many interventions. So as we have listed here, they have done the desludging, they have arrested the solid waste, they started arresting the wastewater. So it has so many drains joining in it. So starting from primary, secondary, tertiary drains. So they started arresting all those drains as well. So even after that, they could not really able to arrest the solid or the wastewater coming from small settlements or from small drains, which exist to bring the storm water from the catchment. So we have been approached to provide nature-based, decentralized solution for that particular context. Additionally, to do the quality and quantity analysis of the particular drain as well. So during our study, we have understood that there are a number of drains. So they have split it into 3 stretches, stretch 1, stretch 2, stretch 3, as it is 12 long kilometer. In order to ease up the work, they started in the first stretch and then done all the desilting and then wastewater mitigation or wastewater plucking, all those. So in this particular project, we have done the Q1Q analysis for the stretch of 1. And then we have identified where are the locations which are, not having safe sanitation, especially the slum settlements, which are very informal settlements located in the periphery of this particular, K100 stormwater drain. So one such location is D'Souza Garden, as I have named it here. So there are about, 30, 40 households, and then about 100 to 150 residents are residing there. So though they have the sewer network, especially for managing the black water, they could not able to connect it, or because of so and so reasons, starting from the clogging, the level issues, silt accumulation in the pipes, and then so and so reasons. Again, the grey water was never connected into such sewer networks. It was connected into small open drains which are located right next to the settlements. So our aim was to treat the grey water again, as some arrangement is already exist for black water management. We wanted to majorly focus on grey water management for this particular slum settlement. So in order to do that, we have done the quantity quality analysis. So the quantity is about 10 to 15 KLD is what we measured using our devices, electronic devices, and then quality is listed here. So the BOD is about 180, at times it also ranged to 250, 300 as well, as because of, at times the toilet black water also connected into storm drains. So the components again, so we want to divert the grey water which is running in or flowing in the storm drain, in the small storm drain. So we introduced interception and diversion, a small interception and diversion arrangement in order to, stop the flow and then divert it to the treatment system. So as you can see in this, in the below image, interception channel, which is the existing small storm drain. And then we have provided silt trap arrangement in order to control the silt entering into our treatment system. So followed by that, an intake structure in the form of pipe to our treatment system. Before that, we also have the pre-treatment of screening chamber. So followed by that, we have introduced our anaerobic decentralized nature-based solution. So in this form, we have introduced settler, where the sediment of solids happen, followed by that anaerobic baffle reactor and anaerobic filter. So anaerobic baffle reactor, as it does not contain much of organic, more treatment happens in anaerobic filter rather than in anaerobic baffle reactor. So it is completely closed system. As I said, it is anaerobic biological treatment system. So as you can see in this, a small drain connecting all the households' grey water and then entering into a major K100 storm drain. So we have plugged the grey water from the drain by this IND arrangement, and then having the screen and then our treatment. So this is completely closed system, as finding the land requirement in the city center is not always easy. So we have used about 15 to 20 square meter area for treating this about 10 KLD of wastewater. And then, the top passage is being used for local people commute. So as you can see in this, the green color painted one, so that is the treatment system on which we are standing on it. So people are using this for commute to reaching out to their households. So this is the illustration, sectional illustration of the same. You can have a look. So for safer side, we are also having the inlet pipe from the sewer network, as they were facing some issues in the form of, due to the blockage, the black water from the sewer network is overflowing, and then it is creating unhygienic environment out there. So we have 2 inlet pipes to our treatment system. So essentially, we are having the primary and secondary treatment, not the tertiary treatment unit, in which we usually have the planted gravel filter or vertical filter type of arrangement. So due to land constraint, we could not go ahead with that particular treatment module, as the state government again taking initiatives to have the constructed wetland in the K100 drain itself. So that will take care of the post-treatment or tertiary treatment. So it is again connected into our K100 storm drain, the treated water. The results are these. So we are getting from 200 BOD, we are leaving at 30 or less than 30. We are also getting 20 at times as it keep on varying. Post this, a tertiary treatment can be able to meet the standards. So the major challenges, as I have indicated, majorly the space constraint, and then haphazard arrangement of all the sewer network pipes, electrical lines, water lines, all these. So again, the clogged and broken sewer line leakage. So it was leaking also from the sewer network pipe during our excavation for setting up the treatment module. So these are the challenges, and then we are still learning from the project how we can improvise this project in many other locations where the slum settlements are still not having the safe sanitation. So a team from Namami Gange program visited our project. So along with this project, they have also visited one of our project called Mahadevpura Lake Rejuvenation, in which we have also set up 1 MLA treatment system. So this was very recently, a couple of days before. Thank you.
Thank you for the nice presentation. Any questions? Yes.
And other places, can we transport this STP water, treated water, and use it instead of potable water, which is being extensively used, or borewell water?
Yes, sir. So definitely it can be reused for construction or for many other purposes as well. So tertiary treatment is not installed in this particular location, as you might have seen that BOD we are reaching less than 30. So it should be met the standards, and then it can be easily reused. And also, in order to have the reuse, or in order to have that collection storage, we need space. So again, the constraint was that. So we don't have sufficient space. So we have adapted to our modules to the available area, not to the required area really. So we have adapted, we have resized our modules to that particular context. But again, so we are reusing the wastewater, the treated water for various other purposes and various other projects. So here the quantity is about 10 KLD. So it can be definitely reused if we provide sufficient modules which are required.
It may not be to your project, but what I want to know is that in a mass scale which they are producing it, are they using it for construction purpose?
So definitely it can be reused, sir.
It can be or is.
So
is a possible proposal. Is being done. Is L&T doing it?
I'm not so sure.
They are using it. Infrastructure for the roads, other things, they are using potable water. Are they using this water or not? Can it be proposed and should be used?
It should be proposed, sir.
Yes.
So in Bangalore, majorly the treated wastewater is being reused for various parks.
That is different. But for construction, is it being used?
No, it should be proposed, sir.
And has it got any detrimental by using it?
No, I'm not so sure about the issues of reusing the treated water for construction purposes. It can be checked. I mean, those who are using can check this, and then we can read through.
Yeah. Yeah.
Correct, sir.
So, sure.
So
Yes.
we can ask them, sir, surely.
Yeah.
Yes, sir.
What is the cost for this?
Sir, for setting up the treatment system, it costed about 7 lakhs.
For
And
7 lakhs, how much we are treating?
So about 10 KLD.
Okay, right. Thank you, sir.
Thank you very much for your
Thank you, sir.
nice presentation. Thank you, Mohan. I would like to thank the organizer. No, it has been given already. Already, this is second paper. So we had 5 presentations. Beside that, Agasab company's presentation. All the presentations were related to wastewater treatment and the reuse of that wastewater. So nicely it has been planned by the committee, and both of us are thankful to the organizers for giving the opportunity. I just hand over the mic to my chairman.
It was a nice presentation by all the presenters. As Sir said, it was totally concentrated towards removal of biological nutrients especially. So we thank all the presenters and the organizers for giving this opportunity for us. Thank you.
Dear friends, it is the time for us the organizers, to thank both the session chairs. I request the former presidents of Indian Water Works Association, B. Srinivas Reddy sir, to come on the dais to honor the session chairs, please. Srinivas Reddy sir, please. Sir, please. Dr. P. Lakshmana Perimala Swami, mentor professor, our Bhartiyar University, specifically Department of Environmental Studies, and the Madam, Dr. G. Brema, who is a professor at Karunya University. We thank both of them for chairing the session and conducting the program. Friends, now it is the time for the lunch time. Please enjoy the lunch. Now let us assemble back by 2:30, please. 2:30, I request all the presenters who are going to present the papers in this session, hand over their PowerPoint presentation details to the technical session, where the technical people are there, along with the computer in the middle of the hall. You please hand over your presentation details to them, so that easy for the next session to conduct, okay? Thank you all.
Ladies and gentlemen. Hello. So, ladies and gentlemen, it is my profound honor to welcome you all to this technical session, 56th IWA Annual Convention, taking place at the prestigious hall, Dr. Usha Kirtilal Mehta Convention Center. We are gathering here on this significant day, the 20th January 2024, to delve into the critical environmental topic that demand our immediate action and collaborative expertise. Our convention themed sustainable management on water and wastewater, latest development, aims to address some of the most precious issues in water management today. We are at the pivotal moment where the sustainability of our water resources is linked to the survival and prosperity of the future generation. I am particularly excited to chair this technical session that focus on the following critical theme. Theme 7, bacteriological modeling and factually derived microorganism in river basin. Here we will explore the innovative modeling techniques that help us to understand and migrate the risk posed by the microbial contamination in our river system. The next technical theme is impact of climate change on freshwater microbial quality. This session is crucial as we examine how the changes in climate is affecting the microbial integrity of our freshwater resources. And third theme is modeling fecal contaminant in the drainage network, as a vital discussion on the modeling of the fecal contamination, which is essential for the development of effective strategies to manage and reduce pollution in our drainage network. Each of these themes represent a fecal complex changes we face and safeguarding our water resources. The purpose and discussion today will not only contribute to our understanding but also pave the way to the innovation solution. So we are very happy and see most of the senior citizens are there. So they enlighten their effort. I warmly welcome all our paper presenters, delegates, engineers, and IWA officials and IWA members and students who have joined us. Your participation and contribution are invaluable to the success of this convention. I am confident that insight shared here will significantly impact our collaborative effect towards sustainable water and wastewater management. As we proceed with this session, I invite my esteemed partner, lead chair, Dr. Prakash Sadi, Honorable Director, International IWWA Headquarters, Mumbai, to lead this session with me. So together we will forward to engage the enlightening the exchange of knowledge and ideas. So we expect many discussions, lead us to more fine-tuning the activity. So we expect paving the provoking thoughts. Thank you once again for being here. Let us maximize this opportunity to learn and to share and collaborate for the sustainable future. Thank you, sir. I hand over the session to the lead chair.
Thank you, sir. My co-chair is Dr. S. Selva Kumar. He is professor in the Water Technology Department in the Tamil Nadu Agriculture University, Coimbatore. And I would like to call the first presenter. That is, the paper's title is Rehabilitation of Existing Trunk Sewer Using CIPP Lining in Nainital and 11 MLD Capacity STP in 2-tier in Dehradun. The authors are Jitendra Tyagi, Rahul Yadav, Avdesh Dikshit, and Sarvana Velan and Sanjay Lalan. So I call them to present here their paper within 15 minutes, and then we will talk about the question and answer.
PPT is already with you. IWWA folder 24. Yeah. Okay, thank you so much. Good afternoon to all ladies and gentlemen, and thankful to IWA team to consider us for presenting here. And some brief introduction for myself. I am Avdesh Dikshit on behalf of Tata Consulting Engineers. And I am presenting here rehabilitation of existing trunk sewer using CIPP lining in Nainital and 11 MLD capacity in 2-tier in Dehradun. Now the brief points are there. Background is in PPT, and sub-project 1 rehabilitation of existing trunk sewer with CIPP lining and 11 MLD capacity STP in 2 tiers in Dehradun. Results and conclusions are there and benefits of projects. The background of the project is we are working in 3 loans of ADB and EIB loans. We are working in Uttarakhand. The ADB project loans are Uttarakhand Integrated and Resilient Urban Development Projects, and second is Uttarakhand Resilient Urban Development Projects in additional financing. And last is Uttarakhand Livability Improvement Projects. We are working with Uttarakhand Urban Sector Development Agency, which is implementation agency under UDD, Uttarakhand under Urban Development Department. Tata Consulting Engineers Limited is consultant for the project preparation and project preparation phases, and the project cost is $250 million for UIRUDP and UIRUDP additional financing, and $325 million for Uttarakhand livability improvement projects. Now, as a first loan, UIRUDP project loan, Dehradun and Nainital we have considered. In additional financing loan, Haldwani, Tanakpur, and Raipur and Nawada in Dehradun area which we have considered. Now the ULIP phase, Haldwani, Kotdwar, Champawat, Kitcha, Vikas Nagar, all these are in Uttarakhand state. Now the first sub-project of rehabilitation of existing trunk sewer with CIPP lining in Mall Road, Nainital. Here we have, we known as Uttarakhand is a fully hilly terrain areas. This project is in hilly terrain and posed many challenges in implementation of the project. The critical trunk sewer stretch existing on Mall Road with from Pant statue to Talital post office. A certain portion of the existing trunk sewer, which is 700 diameter on Mall Road, has reverse gradient in some stretches from Classic Hotel to Talital post office. The existing sewer laid since 1981 to 1982. And now we have proposed the upgradation of trunk sewer network for design flow. Existing trunk sewer need to be either rehabilitated or replaced. But we have here proposing to rehabilitate the existing trunk sewer. The constraint in the project's existing utilities, because the road is very narrow, and one side is shops and hotels are there, and one side is lake is there, Naini Lake is there. Next is stormwater drainage is also there, proximity of Naini Lake is there. The risk of landslide is very high, and habitation dependency is very is there, and other significant considers. And as we have already told you, road width is very narrow. There are approach and methodology we have considered. The conditional assessment we have done, the existing trunk sewer in Mall Road 1.7 kilometer stretch survey has been carried out, and adequate hydraulic carrying capacity of existing trunk sewer for utilization has been analyzed using Bentley software. Based on analysis, trunk sewer, as discussed above, it is assessed hydraulic carrying capacity inadequate to meet 2051 existing flow. To meet requirement of the design year 2051, the existing trunk sewer in Mall Road has to be rehabilitated along the rehabilitation of existing SPS to Children Park. Now, the existing sewer has to be rehabilitated by suitable rehab method to cater the design year flow instead of laying new sewer trunk line. The rehabilitation methods, three methods are there: cured in place pipe, next is machine spirally wound lining, next is glass reinforced pipe, segmental tap. Rehabilitation methods are there. In machine spiral wound lining, a trenchless technology will be used. Glass reinforced involves the glass reinforced plastic liner in the existing pipe. Now, CIPP lining forms a seamless, adaptable lining, reducing disruption and vulnerabilities in the various pipe material and configuration, and adaptability to various material. The step-by-step process of CIPP lining: preliminary inspection design, CIPP liner installation, infiltration, and calibration. Now the curing, quality control, grouting, and sealing. The final inspection, testing, and restoring, and documentation. This is the about cured in place pipe, CIPP pipe, where the minimal dispersion, faster repair time, longevity, durability, versatility, environmental benefits, prevention of future problems. Now the conditional assessment of sewer, where we have doing this CCTV survey, desilting work, and condition assessment. These are the process for CIPP lining. Outcome of the sub-project is the CIPP work has been completed at site in March 23, and the existing trunk sewer at Mall Road is completely operational with any nuisance to habitants in the Nainital Mall Road. These are some photographs which we have. In first photograph, CIPP lining felt tube which has been generated, and the CIPP felt tube preparation is there. The installation of felt tube is there, and the site execution of CIPP lining is there. Now the second sub-projects of 2-tier 11 MLD STP in Dehradun. First is the constant flood risk is there because Bindal River is nearby the STP land. Second is footprint constraint, because we have land constraint. That's why footprints we have to be considered. The address to these challenges, the STP layout was designed in two-tier, ensuring environmental safety and compliance with the treatment norms. Here the sewerage zones of Dehradun. There are two numbers of STPs proposed in the Dehradun in existing project, and the existing STPs are 8 STPs are existing. This is the area where we are executing the projects. Banjarawala area, which have already in 3 packages: Banjarawala package 1, Banjarawala package 2, and Banjarawala package 3, which is in zone 7 of Dehradun. Now the key features of the proposed 11 MLD STP 2-tier sewerage treatment plant. It is SBR based on which a state-of-the-art treatment with complete automation and SCADA. The treatment units are arranged in 2 tiers with the following benefits: to minimize the footprints and to protect potential environment hazards for likely flooding. The pre-treatment units are placed in the first tier, and SBR basin are in the first tier and also second tier. 2 SBR basin in first tier and remaining 2 SBR basin in the second tier. Total 4 SBR is considered in the 2-tier STP. The sludge handling units and allied buildings are placed in the ground level. This is the plant layout of the 11 MLD STP of 2 tiers. This is the process flow diagram, which have considered all the ponds and prawns. This is the hydraulic flow diagram. Now the results and conclusion. In sub-project 1, the site execution has been completed and the rehabilitated trunk sewer is operational. And for project 11 MLD STP sewerage treatment plant in 2 tier, the construction is underway and expected to be completed by December 24. The conclusion are: Uttarakhand Integrated and Resilient Urban Development Project is a testament to sustain urban development in challenging environments. The rehabilitation of the existing trunk sewer in Nainital using CIPP lining demonstrate the importance of innovative, eco-friendly solution in preserving sensitivity ecosystem. Meanwhile, the construction of 11 MLD STP in Dehradun exemplifies the commitment to efficient, environmentally conscientious and infrastructure development. Through these sub-projects, the project team strives to meet the twin goal of improving urban living conditions and safeguarding the environment. And they stand the examples of engineering innovation and environmental stewards, humanity in the suite of resilient urban development. Now the benefits of the projects: environmentally sustainable infrastructure we have done, the use of treated water, reduction in energy consumption, reduction of capital cost and reuse of material and resource conservation, and last is reduction in carbon emissions. Now we have the permission for chairperson to play a 2 minutes or 3 minutes video. Please play the video.
झीलों की नगरी नैनीताल में वर्ष भर पर्यटकों का आवागमन रहता है। शहर की व्यस्तम अपर माल रोड इस शहर की मुख्य लाइफलाइन है, जिसमें शहर की स्वच्छता के दृष्टिगत ब्रिटिश कालीन सीवरेज प्रणाली एवं 1980 पुनर्स्थापना के तहत अपर माल रोड में बिछाई गई मुख्य सीवरेज लाइन को CIPP लाइनिंग क्योर्ड इन प्लेस पाइप तकनीक द्वारा पूर्ण स्थापित किया जा रहा है। CIPP द्वारा पूर्व में बिछाई गई 600 mm से 800 mm व्यास तक के पाइपों का पूर्णवास किया जा रहा है। जिन लाइनों के साइज को वर्तमान डिजाइन के अनुसार बदलने की आवश्यकता नहीं होती है, उन शक्तिग्रस्त सीवरेज लाइनों को CIPP द्वारा पूर्ण स्थापित किया जाता है। CIPP तकनीक में मात्र 2 मैन होल को खोलकर रेजिन इम्प्रेग्नेटेड फ्लेक्सिबल ट्यूब्स को डालकर हॉट वाटर क्योरिंग के द्वारा नई पाइप को मौके पर लाइन के अंदर ही तैयार किया जाता है। इसमें सड़क की किसी भी तरह की खुदाई की आवश्यकता नहीं होती है। इस प्रक्रिया में सर्वप्रथम पुरानी पाइपलाइन में बहते हुए सीवर को डाइवर्ट करने के पश्चात पाइप की सफाई की जाती है और सीवरेज लाइन की डीसिल्टिंग की जाती है और सीसीटीवी कैमरा द्वारा क्षतिग्रस्त सीवरेज लाइन का कंडीशनल सर्वे किया जाता है तथा निरीक्षण के उपरांत लाइन का साइज व गहराई के आधार पर लाइनर की डिजाइन कराई जाती है। प्रत्येक आकार की डिजाइन को IIT से अनुमोदन किया जाता है एवं डिजाइन के आधार पर नीडल फैब्रिक ट्यूब तैयार किया जाता है। इसमें 3 कैटलिस्ट, पहला परकाडॉक्स, दूसरा स्टायरीन, तीसरा रेजिन के साथ निश्चित मात्रा में मिलाया जाता है। CIPP प्रक्रिया को मुख्यतः 3 चरणों में किया जाता है। प्रथम चरण इम्प्रेग्नेशन सेंसेशन। सर्वप्रथम लाइनर को वैक्यूम करने के पश्चात उसमें रेजिन, स्टायरीन एंड परकाडॉक्स को एक निश्चित अनुपात में मिलाकर लाइनर को रोलर कन्वेयर की सहायता से अच्छी प्रकार से फैलाया जाता है और शूटर के माध्यम से कैलिब्रेशन होज के लाइन के अंदर डालते हैं। द्वितीय चरण इंसर्शन। सम्मिलित यार्ड में लाइनर को तैयार करने के बाद पूर्ण रूप से साफ की गई लाइन में डक्ट, रोटर एवं रस्सी की सहायता से स्थापित किया जाता है। लाइनर के दोनों अंतिम हिस्सों को डेड प्लग के द्वारा वायु रोधित किया जाता है। तृतीय चरण क्योरिंग एंड कटिंग। अब लाइनर में पानी बॉयलर एवं पंप के द्वारा एक निश्चित दबाव पर तब तक पानी को भरा जाता है जब तक लाइनर पुराने पाइप की सतह पर अच्छे प्रकार से न चिपक जाए। इस फूले हुए लाइनर में हॉट वाटर बॉयलर द्वारा एक निश्चित तापमान पर हॉट वाटर प्रवाहित किया जाता है। हॉट वाटर सर्कुलेशन के दौरान लाइनर में रासायनिक प्रक्रिया शुरू हो जाती है और फ्लेक्सिबल लाइनर ठोस पाइप का रूप ले लेती है। इस प्रक्रिया के पश्चात लाइनर को मैन होल के आकार के अनुसार काटा जाता है। CIPP तकनीक के निम्न लाभ हैं। इसका जीवन काल कम से कम 50 वर्ष का है। पाइप की सतह चिकनी होने के कारण इसमें गाढ़ सा सिल्ट का जमाव नगण्य है। इस प्रकार एक निश्चित लंबाई में बिना नागरिकों को असुविधा पहुंचाए और कम समय पूर्ण हो जाती है। इस प्रक्रिया के बाद सीवर पाइपलाइन में प्रवाह काफी बढ़ जाता है। भूमिगत सेवाओं में कोई हानि नहीं होती है। सड़क खुदाई की आवश्यकता नहीं होती है। धन्यवाद।
Thank you, Chairperson.
Now, if the questions are there, you can ask.
Yes.
One by one. She is giving the mic.
See, you have considered the rehabilitation of the sewer pipe with the CIPP technology. What about the deteriorated manholes? Because they also must be of the same time, like age factor, we should consider for the manholes also. But that thing you haven't considered in the this particular technology. So what you have to say about that?
Only for sewer purpose, we have already considered for CPHU manual as per guidelines of CPHU manuals.
Okay.
Yeah.
So how you go about the manhole rehabilitation with this technology?
First manhole we are pumping as we are executing SPS from one manhole to second manhole. Then we blank the area, blank the stretch. Then we have rehabilitate with the pipe, CIPP lining.
No, my question is like whole line manholes which are there must be of the same deteriorated condition as that of the pipe. So how you deal about that issues of rehabilitating the manhole along with this technology?
Basically, we have already considered all.
Her question is that what treatment you are giving to the manholes? Pipeline ko you are given the treatment to the pipeline.
Yeah.
But
the sewage is already treated in the STP.
Hello. Here, what their point is that along with the pipeline, have you taken any measure to improve the manhole condition?
Pardon?
Improve the manhole condition, sir.
Yeah, we have already rehabilitated also the manhole conditions.
That's the question. What they are asking.
We have already rehabilitated the manhole conditions.
So how we are how?
For the process which we are considered. Yeah.
Sorry, one more small doubt I have. See, India is a fast growing population in certain areas, like it is
not like 40 years back, whatever population was there in certain region, it's not the same. It's growing with a very fast rate. So this particular technology, we need sewer lines in an increased diameter. But in this technology particular, it is decreasing the diameter of the sewer pipeline. So what is the, how you deal with that particular issue?
We have adopted this technology because of hilly terrain area, because one side is shopkeepers are there and one side is lake is there. So we have no option to rehabilitate the pipe or replace the pipe. That's why we have adopt this technology. Because if we are replacing the pipe, the equipment of the size to replace the pipe is 6 meter or 7 meter. But road width is below 5 meters. Then we cannot use the replace of the pipe.
Okay, but over here, you are saying it is in a hilly area, so the machinery also is very big
Yes,
for this
yes.
particular technology.
Yes.
So you are carrying those machineries, and this technology is reducing the dia. Whereas
We have already done this
Yes,
by
yes,
this
yes.
technology.
But there are other technologies which are increasing the dia by, like with the similar technologies, like pipe busting method.
It cannot be possible in hilly terrain, no? Because if you are busting the pipe, then all the boulders are dispersing on this place.
Okay.
That's why. In all 4 basins are there. Each tier having 2 basins. All 4 basins are there.
You are
Nearly 20 meter height is there. Each basin having 6.5 meter height.
You are rehabilitating this pipeline with this lining, CPP. What about how you are rehabilitating the manholes? The question other
Yeah.
member asked.
We have the process for rehabilitating the manhole also.
How you are rehabilitating? And what is the cost of running meter for this lining?
It's approximately 70,000 per running meter. Rupees per running meter.
So with your permission, sir. See, the life is going to be increased by 50 years.
Yeah.
So you have to dismantle the manhole and you have to rebuild again. That is the answer, but actually I feel. That is supposed to be the answer.
It cannot be possible in the hilly terrain because I already told that one side is already shopkeepers are there. If we are doing pipe busting any methods, then boulders are replacing the spaces, and stormwater drainage is also there. And second side is Nanny Lake is there, so age of the Nanny Lake is also be disturbed.
No, what I mean to say, there is existing manhole which is in deteriorated condition.
Yeah.
So you do some lining or some CC.
Yeah. We have considered the process of rehabilitating in the manhole.
But anyway, what it may be, that needs some rehabilitation.
Yeah.
Whether how you are going to do that separate thing, that I will say.
Per running meter, yeah.
And one more question.
Including the rehabilitation of manhole.
Yes. One more question, madam said about how we are going to cater the excess quantity of the sewage, because by lining that thickness, that capacity will come down. But
Yes.
there is no other go. We have to do it. There is no other go.
What about the projected population?
Yeah.
They are asking about what about the projected population, because the population has increased.
Yeah.
So how you are going to take the care of that population?
We have already considered the projected population, because that's why we are increasing the diameter of the stretched pipe.
In the existing sewer, you are increasing the diameter.
Not existing sewer, not increase the diameter. Parallelly, we have laid the line for projected population.
Okay.
Yeah.
Sir, excuse me. You are telling that 70,000 per meter, running meter. That means about 7 MLD for kilometer is very costly. I think you can go for a new scheme. I feel 70,000 per running meter is very costly. Very well, you can go for
including all system, rehabilitation of pipe, rehabilitation of manhole, and road construction also is there.
The manual rehabilitation is nothing. Just you can go and Plastering, if you do plastering, it is okay. There is no much process for manual rectification. It's very simple thing, just application of cement mortar. I am telling what might be the thickness of lining in that sewer. Thickness of lining, what is the thickness of lining? Probably.
1.25, I think. I'm not sure, but I think 1.25 mm is there.
1.25 mm.
Yeah.
Mm.
Maybe. I'm not sure.
No. This is very essential because it deals with the diameter of the pipe. So, sir, 2 mm. I think you have to re-examine the cost.
Yeah.
No, he's telling per running meter 70,000. Whatever it may be, the 70,000 per running meter. Per meter. Yeah. Okay, sir. Thank you. So everything is done at site itself. Just you are stopping the supply, you are cleaning the sewer, and you are applying lining. That's all. In the site itself, cast in situ.
Yes, intermediate is there.
With the manual to manual.
Yes.
The line is already functioning. You are stopping the supply, you are closing the supply, cleaning the sewer, then you have started applying lining.
Yes.
That is the process.
This is the process of CIPP.
So what might be the age of the pipe, existing pipeline? You are doing lining, very good. What might be the age of the pipe? Already when it was laid, probably.
Yes. We have already done, you can see in the Nainital.
No, he is asking how many years back already the existing pipeline was laid.
Existing pipeline in 1981 to 1982. Existing pipeline are there.
1981.
Yeah.
So as it is about 20
We have already a survey and conditional assessment.
So about 20-year-old pipe.
Yes.
40 years back.
Oh, 40 years, 81, yeah, 45 years. Okay.
Yes.
Thank you, sir. Thank you.
In the existing STP, which technology they are used?
SBR is already.
SBR.
Yeah.
They are constructed in how many year old that was STP was?
I think more than 40 years. No.
Maybe ASP, I think.
What is your question?
Previous technology is activated sludge process, and you are modifying to the SBR.
We have proposed SBR for 17.5 MLD STP.
So what was the existing technology? It
I'm
is
not sure.
maybe ASP.
I'm not sure.
Activated sludge process.
Maybe.
ASP
SPS is there.
SBR तो नहीं है.
Yeah. No, I am from Tata Consulting Engineers Limited. Okay, sir.
Existing is ASP. Okay. Thank you.
Thank you so much, sir.
One more question, please. You have made this project for the projected population. You have made the population with projection for the next how many years?
2051.
2051, okay. The diameter of the pipe, it is suitable for 2051 after your lining?
Not in rehabilitation of CIPP lining, existing dia is 700 mm. Okay. But we have already proposed the networking. We have already proposed the STP, which are under consideration.
I agree with that. But whatever the lining you are doing, that diameter is sufficient for 2051?
Yes.
Your,
we have already considered the parallel line.
That's what I want
Yes,
to just ask.
we have already.
When you can do a parallel line,
Yes.
why can't you go for a replacement? Why did you? Why
Because the parallel line, we cannot propose the higher diameter. That's why we have considered the existing and proposed line.
Can I ask you what is the diameter of that parallel line?
Near about 200 or 250 mm.
Which pipe?
SDP pipe.
Because that point was not there in the presentation.
Yes.
I don't think you have to go for sir.
Yes, we have done. That's why we have proposed a small diameter with parallel line.
Maybe considering the constraint in Nainital due to the hilly area.
Yes.
They have considered maybe.
Yes. Below 5 meter wide.
Yeah. Okay. Thank you, sir.
Thank you so much.
Sir, excuse me.
I don't think any parallel pipeline is required because the sewer is designed for 30 years. Only STP is designed for 15 years and the sewer is designed for 30 years. So I don't think any parallel line is required.
I will give you the answer.
Sir, please.
I will give you the answer to you.
Oh.
Come on, guys.
Next is Dr. Gajanan Khadse. Okay, 1 minute. Yeah. So the title of the paper is Understanding the Role of Cyanobacteria and Dissolved Oxygen in Fish Kill Events in Palsi Reservoir, Amravati, Maharashtra. So Dr. Gajanan Khadse from Neri, he is going to present his views without presentation. Thank you.
Respected chair, co-chair, and equally respected delegates. This presentation was to be made by my student Samruddhi, but because of her some personal issue, she could not turn over here. And as we all were involved in the study, I am discussing the major findings of the project. We know that in recent past, most of the water bodies are facing the cases of fish kill in the water bodies, and whenever water supply is from that water body particularly, even after treatment, rather conventional treatment, water is having some bad odor as well as development of color even after treatment and chlorination. This study was conducted for the Pustli Reservoir, which is located in Shandurjanaghat town in Amravati district 3 years back. It's in the season of summer 2021. There were cases of fish kills, and even that reservoir water was used for supply of Shandurjanaghat Municipal Corporation after conventional treatment and chlorination. And even after treatment, after some time, they could not able to remove that odor and development of color because of the some occurrence of cyanobacteria or blue-green algae, whatever we called it. And then we studied what are the possible causes of development of bad odor and this thing, and why fish kill cases are there. And we observed that the fish kills were occurred because of the depletion of oxygen or dissolved oxygen in the air, which was because of the development of or incoming sewage or urban wastewater in that water body, which was able or resulted into development of eutrophic condition, means enrichment of some nutrients like NPK present in the that sewage or urban wastewater. And because of that enrichment or eutrophication, development of blue-green algae or cyanobacteria were there. Then we have tested that water for different physicochemical parameters and some biological parameters, including various phytoplankton count. And we observed that apart from the various chlorophyceae, ocidilophyceae, and other bacteria, cyanophyceae were there. And cyanophyceae are the cyanobacteria which are helpful for fish kill. Those are cyanobacteria. During day season, they help or they perform photosynthesis, and because of this daytime photosynthesis, dissolved oxygen is up to 7 to 8 ppm in the water body. But during night hours, that because sunlight is not there and the algal growth cannot make any photosynthesis, there is depletion of dissolved oxygen and reduced below 2 ppm in the water, and because of depletion of dissolved oxygen, fish kills were there. Apart from depletion of dissolved oxygen in the water, the fish kills were also because of the cyanotoxins presence, because of the secretion of cyanotoxins present in cyanobacteria. And almost 23% phytoplanktons were because of the cyanotoxins. And we do some post-mortem studies for the killed fishes in our veterinary department in Nagpur Veterinary College, and we observed that fish kills were because of the septicemic hemorrhage, which is a kind of killing of the or rupture of the blood vessels in the fish tissues, veins of the fishes, and because of which fish kills were there. And we have suggested some remedial measures for in order to get rid of this problem, and we have suggested advanced oxidation process for or pre-treatment or pre-oxidation before going for conventional treatment, so that whatever algal growth or blue-green algae are there, there is a rupture of cell and which help in removal due to coagulation flocculation. If these blue-green algae are as such in the water, they cannot remove with conventional treatment, even after application of alum, lime and conventional treatment. We need pre-oxidation for rupture of the cell so that we can remove it with the coagulation and flocculation, and also some efficient method for this thing. And after our recommendations, the municipal corporation Chandradana Ghat would get rid of the problem of occurrence of bad odor and your development of green color in the wind. Thank you very much. Thank you, sir.
So it is open for the questions.
Yeah.
Sir, you said 8 milligram per liter DO.
Yeah.
It's a lake? Or
7 to 8 lake water in daytime only.
Yeah.
But in night time, we get that DO reduce up to less than 2 mm because photosynthesis is not there. Normally, 6 to 8 ppm DO is always there in clean water when the water body is pristine one. But presence of blue-green algae or cyanobacteria or any algal growth plays dual role. During night, when photosynthesis is there in the presence of sunlight, we get good DO up to 6 to 8. But during night, in the absence of photosynthesis, that is reduced down because of the BOD, presence of fecal bacteria and other organic material because of the incoming sewage, that dissolved oxygen is suddenly reduced out during night time, and because of that fish kills were there.
It's a polluted water with incoming sewage?
Yes.
Then also 8 milligram per liter is there.
Sorry?
It's a polluted water with sewage, because of sewage it is getting polluted, but then also 8 milligram per liter is there.
Polluted because of some urban wastewater, and some catchment also bring some nitrogenous, phosphorus and potassium fertilizer from the catchment area. Because of presence of these nutrients in the water, it results into the eutrophication of water body, and that eutrophication result in the occurrence of those algal growth in the water body, which we call as cyanobacteria.
Thank you, sir.
Yes.
So it is quite natural if you mix wastewater sewage from sewer, automatically the dissolution will be less. See, it may be 8 ppm. When the water is good, it is 8 ppm. If you are applying your mixing wastewater, naturally the dissolution will come to 0. It's no doubt.
Yes.
Yeah. So only in course of days, during oxidation only, again we can recoup the dissolved oxygen.
Whenever we use the water treatment, we undertook such study for BC reservoir in Chandrapur district also in last summer, and they were not able to remove that algal growth. Because algal growth impart greenish color, as well as it imparts false turbidity also. Even if the water body is having turbidity below 5 NTU, in the presence of the cyanobacteria, blue-green algae, that turbidity results shows up to 20, and we cannot remove that turbidity, false turbidity rather, because of the presence of the cyanobacteria, blue-green algae, and we need to have some advanced oxidation process for rupture of the cyanobacterial cells so that we can get better results after coagulation, flocculation and conventional treatment. These studies need to be conducted in hereafter. We need to conduct such studies in most of the reservoirs wherever the occurrence of this green algal growth is there in the water bodies. Otherwise, we may not get the BC, Chandrapur district, BC village is there. They were facing a lot of problems in last summer, and they are going for alternate supply. And this thing we undertook such study for those reservoirs also.
Yes, sir. But anyway, nowadays, there is, I think, only effluent, treated effluent you are mixing with water or river lake. Nowadays, nobody is allowing wastewater directly into the river.
No,
But of course, depends on the...
Even if the sewage don't mix with that water bodies, but if the catchment is fertilized and any organic matter from agricultural fields appear in this thing, and any anthropogenic activities or rearing of cattle and any activities in the catchment area, if it brings nutrients and organic matter in the water body, definitely it will develop blue-green algae in the reservoir. It is not essential that the sewage should come in the water body and then and only then development of algal growth is there. It is not like that. It depends on the characteristics of the catchment from which the water is coming into your reservoir.
Yes, sir. Thank you very much.
Thank you very much.
So fish kill is taking place in the specific months or specific time?
During summer, the problem is exaggerated, sir. Yeah.
And time is in the
May.
early morning.
May. Fish kill we find in the early morning because of the fish kill during night hours. We get fish kills in this thing. Yeah.
Because normally it is observed in the 3 to 5 because there is DO is minimum. And
Yes, yes.
due to that it is taking.
Yes.
Okay. Thank you.
Thank you.
I request Mr. Atul Maldure to present. His title of the paper is Review on Treatment Technologies for the Removal of Cyanobacteria from Drinking Water.
Sir, which name, sir?
Atul, Needy. IWWA, Atul, Needy. You got it? Yeah. Yeah. So, good afternoon, respected chair and co-chair and all delegates. I am Dr. Atul Maldure, principal scientist from CSI Needy, Nagpur. So I am going to talk about the sequence a little bit change. I supposed to talk earlier or prior to Kharche sir. So I am going to talk on the cyanobacterial blooms. Why cyanobacterial blooms or why it is said to be a burning topic, because it's a gift of climate change rather and upcoming issue for the all water workers. So that's what as a Needy we are getting requests annually. We are getting like 4 or 5 requests from various water supply departments, rather municipal corporations for the related issue, and mainly in the month of March, April, and May, and up to 15 June. And that's a real task. Why? Because yeah. Why it is tough? Because water is considered to be one of the under sustainable goal, comes under the sustainable goal, and it's a right to everyone. And when we go for the when we visit the various water bodies, we can see the harmful algal blooms. These are the growth of algae over the water and beneath the water. That's the algal bloom, said to be the HAB nowadays. And when we go through the various reports and newspapers and news channels, we can see a lot many news related to the proliferation of the various lakes in India, and obviously this is a situation in abroad even though. When we check the situation all over the world. Yes, the outbreak of the algal bloom we can find out in all over the world, not only in the India. So this algal bloom proliferate in the mainly dry environment, but in the US and other states also they started getting the this bloom issue. The main so when we go for this cyanobacterial bloom, why it comes nowadays? Because when we go through towards all the reason and finding out the probable the situation why it comes. These blooms or cyanobacteria is not something the gift of today's or say it's not a new species in the world. It's a old species was there, but because of the control environmental condition, their growth was limited, and that's what they doesn't come with the huge population. Now they are started showing their existence because of the favored condition to them, like dry environment, increase nutrient concentration in the water, and all the favored condition for them, and that's what they get proliferate and in the higher concentration. Yeah, as I said, the cyanobacterial is a gift of combination of all the processes like anthropogenic activity, agriculture runoffs, industrial activities, alter precipitation patterns. As we know that the quantum of water is there, we'll get the same or equivalent amount of rainwater, but the number of rain event has been decreased substantially. That's what number of flood events has been increased. Elevated CO2 is there, and intense light and intense temperature and all these things. So all these factors combinedly force the energy, gives the energy to cyanobacteria to grow in the water bodies, and finally we'll get the water body in the, finally we'll get the algal bloom in the water bodies. So when we go through the science behind all these things, why it is problem to the WTP workers, these are the few species under the cyanobacteria. Actually it's algae, known to be as the cyanobacteria. These are the species which having a small gas void on its top, and that's what, and they are slightly negatively charged, and that's what they don't get settled down in the conventional WTP, and that's what they are creating problem in the conventional WTP. So what's a guideline? These are the various guidelines in the various countries. So we are following WHO guideline in our country. So in India also there are guidelines available for the cyanotoxins. Cyanotoxins is something which is there inside the cyanobacteria. When we rupture the cell wall of the cyanobacteria, there's something from the entire things comes out, and which is water soluble, and it is said to be cyanotoxins. And there are the limits which already been set for the cyanotoxins. Why? Because they are carcinogenic and they have various health effects that I will show. So these are the cyanotoxics, various chemical structures, and these are the cyanotoxins which impart the taste and the odor to the water once we rupture it. There are a number of the health hazards has been established already based on the various studies in the animal as well as in the various in the human even though. So these are a number of things which could be possible, or these affects our body entirely. Okay, we just take an example of one of the lake, which is reservoir, which is there in the Latur in the Maharashtra. As the Latur entire Latur area is a dry season, and which is a host. I would say dry season is a dry area is the picnic spot for the cyanobacteria. So the entire city get water from the Manjra reservoir, which is around 50 kilometers from the Latur city upstream of the city, and the lake water started greenish with the time, which is in the month of May, these are the few pictures at the site, at the reservoir, even though we can see the greenish algal growth in the WTP, which is there in the Latur itself. So the people started getting complaints of yellowish water with the false smell, with the bad taste. because these are the cyanotoxins which are responsible for the various cause. Test different type of cyanotoxins, smell different type of cyanotoxins, which is because of the bursting of the cyanobacteria and the water may be there inside the cyanobacteria get out in the water. And these create various issue, right? No one drinks the yellowish water. When we check the water quality and all these things, the pH of the water is 8.3, which generally which is not common. Why it is 8.3? Because the cyanobacteria consumes alkalinity from the water, and that's what it releases OH, and that's what the pH would be higher because of the OH radical. There's a science behind it, and turbidity is fairly low. 5 to 7 is not a higher turbidity, and dissolved oxygen is 5 to 5.4, and at intake well it reduced down because maybe higher population or the shaded area. So low DO may be due to the proliferation of algae and biomass entering the oxygen, exerting the oxygen demand. And again, the DO is the function of time when we check the DO. And our observation is that these cyanobacteria are the very brilliant species. During daytime, they settle down to the ground, to the surface of the reservoir, and during night time it comes up. So one of the tack to handle them, during daytime extract water from the upper surface of the reservoir, from the night time extract the water from the downstream of the from the surface of the reservoir. This is one of the tack to tackle the cyanobacteria even though. So, so exact how to check the what was the reason, biological reason. So we check the phytoplanktons density and we try to postmortem everything. So we found that the raw water is having high amount of phytoplankton density, and after treatment, even though it doesn't get down to zero. It's supposed to be practically zero, but it doesn't get down to zero, and that's what it leads to the various factors like pinkish color, yellowish color to the water. And the cyanobacteria is one of the highest percentage, about 75% in both the things. And the indices and all these things we go through, it shows that yes, there is a presence of cyanobacteria, organic load in the water. And there are various kind of, we just segregate the n number of the species of the cyanobacteria. So there are the species which are the more dominant for the higher organic load, for the producing toxins, potential harmful, and there are the species which are responsible for the various human health hazards. So that we like categorize and identified and quantified them, and what to do with the, how to handle that situation. Now people are getting yellowish water, so how to handle that situation? To handle that situation on trial and error basis at the limited condition in the district laboratory, we find out various ways. We use alum, we use PAC, we optimize the PAC, that dose is up to 35 to 40, depend on the time, even though it changes. We use lime to enhance the turbidity, and after that we use the chlorine gas, which is again higher side, because we need to kill the algal growth, and which is supposed to be get settled down in the WTP itself. And supposed not to be carried forward. And the main culprit, what we found after with time, that's rapid sand filtration get choked out, because the cyanobacterial load get stuck into the rapid sand filtration, and it choke the entire things, and it stop its functioning. So instead of that rapid sand filtration, obviously one of the option is to use the ultrafiltration if possible. So that can be change the scenario. We get clear water, no issue gets solved, but at the cost of high dose of alum, PAC, that increase the risk of AL in the aluminum in the treated water. Very high dose of chlorine, that increase the risk of DBP's disinfection byproducts in the water, because the presence of organic load is there already because of the phytoplanktons, and the free chlorine that can produce the DBPs, which are again harmful and already proven, and high treatment cost. So this is what the cost for the getting treatment water. Challenges for the drinking water treatment plants, yes, because of the harmful algal growth, degraded water quality in terms of various water quality parameters, traditional process not effective at that particular time because of various the issues what we discuss now, elevated concentration of organic load, organic matter in the entire water, and the clogging of rapid sand filtration, and the gift is the disinfection byproduct, which is again harmful to human health. So nothing is been clear as of now. Like US EPA documents speak about that, but they doesn't have any clear guideline like what should be done at the time, right? So there are few unwritten things are there, like algicides are there. Someone somewhere wrote that algicide can be used. Rapid sun filtration is a defense. I would rather suggest use UF, ultrafiltration if possible. Oxidations are there, sedimentation are there. Like these are the unproven technologies. But again, I have objection on the oxidation, because oxidation kills that cyanobacteria and the cyanotoxin comes out in the water, which is not good again. So what need to be done as per my previous work from the last 2 years on this topic, we need to partially oxidize the cyanobacteria. Cyanobacteria is having one small gas bubble on its top. So we need to rupture that. Once we rupture that, the gas bubble, through the partial oxidation, that in that condition, it could be settled down in the WTP itself. So after that, the things could be in our hand. So the partial oxidation could be one of the best option. We are working on it. One of the PhD student is working on it, and we'll probably next IWWA convection will be with the good results on the topic. So multi-barrier approach should be there, should be adopted. Prevention is the best practice, obviously in all conditions. Condition control, water uptake and treatment. So these are the multi-barrier approach. I am proposing that these multi-barrier systems should be adopted for tackling that issue. And this could be the issue with nowadays or last year, maybe 10, 15 WTPs get that issue. Next year, more number of, and after that, it will be increased, because it's a gift of climate change and various enhanced anthropogenic activity and other activities which favor the cyanobacterial growth in the water bodies. So concluding remark, I will like to stop here. In concluding remark, I would like to say like complex interaction of environmental, climatic, anthropogenic factors has intensified this proliferation. More comprehensive studies are needed. Now, as per my knowledge, there is no any technology which is there as a thumb rule that use that technology and get clear water from the cyanobacteria, get rid of the cyanobacteria. So most comprehensive studies, I think, required. And detection is the issue actually. In the early stage, we don't have any mechanism to check, to identify the cyanobacteria when its growth was low or when its density was low. So that's a research focusing on monitoring or early detection strategies are required. Actually, the cost of the detection is quite high, and there are the techniques which are not possible for even the district water testing laboratories or most of the laboratory. So that is the issue again. And as I said, integrated techniques is required to tackle that issue. No one, as per my understanding, no single technology can tackle that issue at this point. So thank you for the patient listening. Yeah.
Any questions from the audience? So this is the issue which is very common nowadays, even in Karnataka also we have seen. We too are bothered about this also. You mentioned that actually high dose of chlorination leads to some byproduct, something like that actually.
Yes, sir.
Disinfection, some toxins and all that. Of course it is there. Is there any alternative disinfectant, like you also in NEERI have sometimes recommended even silver ionization and all that. Is that okay?
So silver
at least for smaller units.
Okay. Sir, silver ionization and all these things are good, but at the scale of WTP, at the scale of municipal corporation, chlorine I think is the best and economic viable things, because it have residual effects. After chlorination or after dosing, it will remain there in the water for some time, right?
Yeah, residual chlorine is required, sir. But I mean, we are overdosing it now.
Yes.
So naturally, over residual chlorine will be also there, which is harmful for our conveyance system and as well as our consumer.
Sir, actually organic load is high in the water, so higher residual chlorine won't be issue because it will get consumed because of organic load. So at the consumer end, you won't get any residual chlorine because in between you have both the things, like you have fire and you have ice with you, so both things will neutralize, right? So like that, if you have organic load, you have chlorine, so obviously it will get neutralized or it get consumed with time.
Okay.
And that's what the yellow color comes at the end.
Yeah, no, that is very common now.
Yes, sir.
Yes.
And it's a common, and I just take an example of the Manjra. It was the case of 2022 in the Venara Dam in the Nagpur, Kanan River in the Nagpur,
Yes,
Surat.
yes.
Everywhere we are getting at least 10-15 inquiries every year now from last 3-4 years, and now the frequency will increase. So even though we handle the 650 MLD WTP at Rajasthan in 2019 somewhere. So this is an issue in the almost all dry state at this moment we are facing.
Yeah, of course. Now you are telling that there may be other conditions also.
Yes, sir.
Maybe you are experimenting directly only in Maharashtra, this may be the condition. But I think elsewhere also this condition should be there. Since NEERI is a common institution, actually, you make a recommendations to the government of India also.
Sir, actually we are working on it, and my one of PhD student work on partial oxidation. I don't want to harsh oxidation, and partial oxidation simply brush that the gas oil or bubble on the cyanobacteria. If that get crash, the cyanobacteria can say settle down. We can settle down in the WTP itself.
In the WTP itself.
Lab-based experiments are done. Very frankly, lab-based experiments are done, but obviously lab and the scale, we are dealing with the 30 ml.
Of course, no, it's very big.
It may take some time.
Yes.
But we crack the science. We crack the science.
Because, sir, problem with us is actually now I am from the rural background. Jal Jeevan Mission, now our approach is the surface water only. The surface water now we are tapping from this reservoir source only, and this is a common issue. We are adding to a problem only.
Yes.
Because we are having a conventional treatment system only. I think we need to do some carbon treatment, something like that, yes, sir. Some resin and all that actually.
So carbon won't work because of the pressure drop and all this thing. Ultrafiltration will work. That was.
But ultrafiltration is a very high power.
Obviously at WTP at this moment maybe like maximum audience won't accept it. But my opinion is that ultrafiltration will work. It comes with the low capital cost compared to sand bed filtration. Yes, for the ultrafiltration maintenance cost would be high, but the capital cost and the land cost would be low in case of UF.
So what our approach was like this, sir. My idea was this, that have a conventional water treatment only for the consumption, drinking purpose only, go for the CPPs only. Whatever even the ministry, Niti Aayog also has suggested, wherever the arsenic fluoride is there, and also I think actually CPPs will help this.
Okay,
because consumption is hardly 3 liters, 4 liters,
right.
Drinking water per head.
But for that we may require again the second pipeline and all these things, sir.
No, not parallel pipeline, only common this thing, separately for drinking. In those areas, that period actually we should make it mandatory.
Yes. But this is an issue, coming issue.
Thank you so much.
As you say, silver ionization, sir, but silver ionization cannot be substituted for our conventional chlorination. Because in conventional chlorination, we conventionally treat the water and supply to the village or a town or city. But silver ionization is normally used in hand pump attachable or some groundwater or some community supply, railway station, bus stand, school, likewise. But this silver ionization cannot be substituted for chlorination in conventional water treatment plant. And as you say, the 2 to 3 liters will be sufficient for safe water supply in fluoride affected area or arsenic affected area. I will say 10 liters per. Because in addition to drinking purpose, for cooking purpose also we need fluoride free water. Yes.
Yes. It's an alarming situation, and we are on the topic from last 2-3 years. We are working on the basics of all the things.
We were thinking like something different, sir, actually. We were adding the bleaching powder directly to
Sir, I actually, we can't replace the WTP. We supposed to work in the boundary of WTP, so that the entire intention is that we have to add something prior the water entering into WTP. So we do not, the technology which is replacing WTP can't be viable. So we supposed to have substitute, add-on thing kind of to the WTP. So that would be the sustainable technology as a,
one more thing, sir, I would like to say, because you are telling the oxidation as a sub-problem. But even the chlorination also, chlorination do have a problem also.
No,
So I prefer oxidation to the chlorination actually. I don't know what.
Yes,
As a scientist, you must tell us.
Sir,
as a technologist, I find oxidation is far better than.
The discussion can be gone on
sir,
this particular.
sir, my,
So next question.
Yes, sir. As per your the characteristics mentioned in the raw water, the turbidity is in 5 to 7
right.
only. So with your treatment, how any other additional treatment you are given to reduce the turbidity, or whether it is the sludge is added before that for better coagulation?
Sir, in that condition, for that WTP, it is not possible to recycle to recycle the sand bed water into the WTP itself. So that's what we use lime there to enhance the turbidity, because in such situation enhancement of turbidity works sometime. That's what we use in 2019 in Nagpur, and even though in 2021 in Nagpur again, there's some different WTP. So enhancement of turbidity works. That's what we use lime here, and simply to enhance the turbidity and to get rid of
Lime actually we are using not for
it
this
is
one.
it is not recommended.
Yeah.
If you have the facility of say recycling the
We have to increase the turbidity, then we have to add the appropriate quantity of lime, alum or something, then to neutralize it, lime is adding. That is the proper method, is it?
Yes. If you have backwashing facility, like backwash water can be recirculate to WTP, then it's a best practice.
Yeah.
But
here what
the
method you are adopted? Or any suggestion is there? Because this is an experimental method.
Yes, recycling is that works actually. We use it the same recycling things at Nagpur. I think 250 MLD plant was there. So we used that practice in 2019 and it works. So recycling helps to enhance the turbidity. Our main intention was to increase the turbidity by any way, like any mean rather.
Yeah, okay,
so recycling is the cost effective in that way.
Recycling is required.
Yeah, it's required.
Okay,
If the turbidity is too low, reducing turbidity from 100 to 5 is easy compared to reducing turbidity from 7 to 3.
Hello, you talked about multi-barrier approach.
Yes, sir.
How it helps in
Sir,
solving the issue?
Multi-barrier approach, it means it covers everything like the prevention of, it has gone, okay. Prevention of safeguarding your water bodies and all these things. So it's a multi-barrier approach. Ye bhi na ho, wo bhi na ho, like kind of thing. So, in the treatment portion, multi-barrier approach is advanced oxidation without chemical, like physical oxidation we are proposing. And side by side we are proposing 2 to 3 more things in the WTP with the cost effective way. That multi-barrier approach, like 50% by this technique, 50% by this technique, and by considering everything should be cost effective. So that was the multi-barrier approach, not a single approach. Like chlorine is, if you are using chlorine, that's a single approach. If I use the 2 to 3 technique, if I use the UF, that's a multi-barrier approach in addition to advanced oxidation, sonication and various things. Physical oxidation, that I wanted to say.
Thanks.
Sir, we had discussed about the growth of blue-green algae, that is a cyanobacteria. But on the other side, we ended with adding 6.7 ppm of chlorine. So if you add 6.7 ppm of chlorine, probably what will be the residual chlorine? I mean, minimum available based on your study.
Sir, it is depend on the condition on organic matters, how much it get consumed.
Okay.
So
the
is
very
depend on
minimum should be 0.2 ppm, that's okay. And generally it may be some 3 to 4 ppm, it is okay. After adding 6.7, what might be the available after 1 or 2 days or as per your study? What is your the chlorine available after adding 6.7 after some reaction?
Sure, that was fixed based on a trial and error basis, and in the treated water we keep it around 1.2 somewhere, so that the residual the organic load can consume it. So that was the approach, to keep it is 1 to 1.2. That was the target. Accordingly, we finalized the dose. So that was the demand actually. And according to demand, we have provided the chlorine. And that was the only option that time.
Yeah, okay. So there is no other method, whether periodically cleaning of this algae, periodical cleaning of algae. You said there is no measuring device, no mechanical device to algae and all. Why not by volume or by weight, by collecting? Or why not we can apply periodical cleaning of, remove the algae, periodical removal of algae in the water body, so that these minerals will be there.
Sir, these are the minute or small size particles. Cyanobacteria or algae is not something which is there floating on the surface. These are the small particles which you can't be take up by screening or whatever may be the physical mean. These are small. They can bypass your sand filtration, rapid sand filtration. So they are small size algae. So that is the issue actually, which is non-settleable.
Yes, sir. Very good, sir. Thank you.
Yeah. Thanks.
Any question? Okay. So, thank you, sir. Any other presenter is present of this session, he can present his presentation. If not, we can conclude this session. कोई नहीं है? Anyone presenter is there? Next one. Next four. Okay, no one is there. I have already one. You can announce once.
Is Ramya and team here? Swastik Pandey and team? Dolly Krishnan and team? No one. Deepika R and team? No. No. So good afternoon, everyone. So here is the brief CV of the technical chairs today. Dr. Parak Sagdir. He is a professor and head, Department of Civil Engineering at COEP Technological University, Pune. Sir is Director International in IWA 2023 to 2025. He is also a recipient of Jal Seva Award from IWA. Sir has guided 5 PhD and 32 MTech scholars for the degrees. He has published 1 patent and more than 140 papers at international and national level. He has completed more than 80 consultancy assignments and water supply and sewage treatments specialized in decentralized wastewater treatment. And the next session, the co-chair is Dr. S. Selvakumar, Professor, Soil and Water Conservation Engineering, Center for Water and Geospatial Studies, Tamil Nadu Agricultural University, Coimbatore. Sir has completed his PhD in Soil and Water Conservation Engineering. He has a professional experience of 17 years. He also is in charge of various laboratories and has initiatives such as the Environmental Engineering Laboratory, Atomic Absorption Spectrophotometer Laboratory, Groundwater Recharge Demonstration Unit, and the drip automation system in the irrigation cafeteria. He has 15 external funded projects, and his key achievements led to the development of state water policy and large-scale precision farming demonstrations, watershed development, irrigation automation, design and development of accelerated groundwater recharge structure, innovation in the domain of constructed wetland treatment system for industrial wastewater, and he has developed sensor for assessing soil moisture in the paddy field schedule, the alternative wedding drying irrigation. Thank you. To felicitate Dr. Parak Sagdir with a memento. Thank you, sir. I invite Basant Kumar to felicitate Dr. S. Selvakumar with a memento. Thank you, sir.
I request all the presenters to come on the dais.
The esteemed delegates, distinguished guests, our senior IWWA members, as we come to the close to this enlightened technical session of the 56th Annual Convention of Indian Water Works Association, so I am filled with a deep sense of gratitude and impression. For the past 2 days, we have embarked on a profound journey of knowledge sharing, exploring and interactive discussion and innovative solutions in the realcom of water and wastewater management. So the paper Innovation in Infrastructure Rehabilitation, the presentation by Jitan Kyagi. So I have highlighted the rehabilitation of existing trunk sewer using CIP lining. So in this presentation, the senior peoples highlighted the several things to sharpen the technologies. So they need to address the challenges of aging water infrastructure in the urban settings. Then advanced treatment technologies like removal of cyanobacteria from drinking water. So highlighted the importance of innovation in ensuring the safe drinking water. Their insights are invaluable in the context of increasing water pollution in the public health is concerned. So in conclusion, let us carry the knowledge and impression gained from these sessions into our respective field. Let us collaborate, innovate, and tirelessly work towards the sustainable management of the waste and wastewater to the benefit of the all. I extend my heartfelt thanks to all the presenters, participants, and the organizers, and the senior, especially the senior members who spend more times in the hall. So I also sincerely thank the lead chair of this session. So I thank you one and all for this opportunity, and thank you for the organizers.
Is already closed. For the members who are sitting here, our request is, those who are staying far away, they can be here only, because as you know, the banquet dinner, what they have arranged is too far from here. The hotels which are on the way, starting from Hotel Niveda, Swarga, and Mukambika, which are on the way, they are going to pick up at 6 o'clock. Only those hotels, majority of them which are too far away, which is not in the main road, they will not come. Better to be here only, that the buses starts at 6 o'clock to move towards the convention center for the banquet meeting. So my request is, please be ready at 6 o'clock. Now, those who are nearby in the hotel of either Niveda, Swarga, and Mukambika, they can go there and they can relax and get ready by 6 o'clock, please. And dropping will also be done from the same buses. Thank you all. And my request is for all the students. Dinner has been arranged here only for the students from 7 to 9 o'clock. Please come and have your dinner for all the students. The youth forum students and all the things, they can join here only. The evening dinner is arranged here only for all the students. Those who have got the passes and all, they can move towards the banquet dinner where they have arranged far away from this place. Please take a note of this and act positively. Thank you all. Have a good day.